Good morning, ladies and gentlemen. My name is Donald McGavin, and I'm a colleague of Dr. William Hadlow, who will be interviewed this morning in one of the series of the interviews for the Charles Davis Foundation. These are interviews with prominent veterinary pathologists, and we hope to explore with Dr. Hadlow his life, particularly as he is well known in the field of transmissible spongiform encephalopathies, initially with scrapie and more lately with bovine spongiform encephalopathy. Some essential details of his bibliography are that he was born in 1921 near Cleveland in Ohio. He grew up with his parents on a poultry farm at that site, graduated from high school there in 1939, enrolled in animal husbandry at the Ohio State University in January of 1940, and then switched to veterinary medicine in June of 1942. His studies were interrupted by the war, and we hope to hear more of those experiences in the interview, and he graduated DVM in March of 1948. He went into graduate studies, particularly in neuropathology at the University of Minnesota, and then ultimately ended up at the Rocky Mountain Laboratory in Hamilton, Montana in June of 1952, and most of his life was spent there, except for some interesting interludes, including 3 years in England. So these are some of the things that we hope to explore. Welcome, Bill.
Good morning, Don.
Could you tell us a little about your upbringing, and particularly about, well, obviously you were alive during the Depression, and which was a hard time for a lot of people. So what was life like at that time?
Yes, it was surrounded by poultry.
Mm-hmm.
Didn't really recognize any of the dire effects of the Depression. Always had plenty to eat.
Mm-hmm.
Usually a lot of poultry. Had our own garden. And so we got through the Depression without really realizing the adversities that many of the other people did. Well, then I left Cleveland after I graduated from high school. Went out to California for a brief period as a carpenter's apprentice.
Oh, okay.
And I stayed with an aunt and an uncle out there, and my uncle convinced me that, or encouraged me to do something else. And it was at that time that I decided to go to the university.
But what part of California was
that? Was in
this?
Vallejo. It was north of, just north of San Francisco.
Uh-huh.
And helping an old retired carpenter build homes. That was fun. I'd always been around home. We had to build our own things, so I'd gotten used to that sort of work.
Tell us a little more about the conditions back in West, your home.
In West Park?
Yeah.
Well, we had, it was acreage. It wasn't a big farm. Our playground was a 500-acre pasture across the street, and it was surrounded by various teamsters who maintained horses that were still used in those days for work. I can't recall much of, there was a woods on the place with a creek running through it. That was a great place for the kids to play. So it was a pleasant childhood during that Depression period.
So what sort of animals and birds were around?
Well, we had, I mentioned it was poultry, and of course there
what was the poultry in those days? What were the
Well, we had chickens, some of the old breeds that you don't deal with
Rhode
anymore.
Islands or?
Rhode Island Reds. I think the main one we had was the dark brown leghorn, as far as the egg layer.
Yeah.
And then I think
brown eggs, right?
No, they were white eggs.
White eggs?
Yep. And probably the main enterprise was raising squabs.
Oh.
And well, that was as far as making the enterprise productive, selling squabs to a provision house in downtown Cleveland, and these were used then by the hotels. And it was a real high-priced food item in those days.
So how many birds were there, and what was the production rate? And how
well, I can't remember the details. We tried various breeds, but in the end, the breed that produced the best squab, which was supposed to be a pound, nice rounded breast, white without a lot of hair, pin feathers, was a white Carno that we got from a pigeon plant in Sumter, South Carolina. That was the main one. And I think my dad made some money on that.
Right.
Then we had a lot of pheasants, not only some of the fancy varieties, but we used to raise ringnecks for some of the game clubs. They'd release them for their shoots.
Right.
And we raised turkeys in those days. That was in the time when histomoniasis was a big problem, but for some reason, my dad decided to raise them on wire away from chickens, and that was the secret in raising,
wonderful.
raising turkeys without problems. We had ducks, some wild ducks, white pecans, muscovy. My dad didn't allow peafowl. They were just too noisy. So it was that sort of surroundings of, and then all the, and various kinds of chickens, but mainly the brown leghorn. So that's what made up the poultry on the poultry farm.
And these horses that you talked about, these ones used for what, ploughing and?
Well, plowing and then just commercial work, because horses were still being used as draft
wagons,
power.
right.
Didn't have that many trucks. They pulled wagons. I watched them make the road in front of our place, and they did this with the old dump wagons.
And what breeds were these?
Well, I don't know. They were a mixed breed. There were horses that were...
It wasn't Suffolk or some of your...
No, they weren't any standard breed. I think they produced a halfway decent draft horse that probably weighed 1,200–1,300 pounds. Most of them use that.
And how far did you have to go to school, in grade school?
Walked to school, and...
half a mile? Mile?
No, a little less than a mile. And then at the other end, going in the other direction about the same distance, we could get to a streetcar. And that would take us to downtown Cleveland. So we were out in what I suppose they'd call today the boondocks, cleared out on the edge, when this little village of West Park was annexed into Cleveland. So that was the sort of environment in which I grew up, and didn't have any idea what to do after high school. Didn't
So
give
what was
any
high
thought
school?
to
What
go
was
to
the instruction
university.
like in those days in the school and in the high school? What do you remember about the actual experience and the atmosphere in the school? And
No, I'm sure it was quite different than it is now. It was run with considerable discipline. The principal didn't tolerate any nonsense. And there were the usual things that kids get into, but you were dealt with rather harshly. So it was a pleasant experience. And I think that was just the general tenor of the times. You towed the mark. You didn't try to balk or make for difficulties with the people who you had to deal with. So,
well, you must have felt fairly well prepared to be able to go from high school into Ohio State.
I really wasn't, because I didn't take a college preparatory curriculum in high school. I had in mind I'd probably be a carpenter. And that's the reason I went out to California to start a carpenter's apprenticeship. And anyway, as I say, an uncle out there encouraged me to do something else, and actually went to Davis, California to see about enrolling there, and whomever I spoke said, well, you better go back to Ohio, it would be cheaper, since I was a non-resident.
What was actually at Davis in those days? This is 1940?
1940.
What was at Davis?
Well, I went there, late in 1939.
Yeah.
They had a good animal husbandry department there. And that's what I was interested in. Anyway, I wound up at Ohio State University in January of 1940. Enrolled in the College of Agriculture and Animal Husbandry. And my professor was the swine husbandman. So every day you had to judge a ring of hogs. And of course, it was at the time when judging livestock was important. And if you were going to be, if you were going to major in animal husbandry, that was one thing you had to gain a certain proficiency in, and it was emphasized. It was a good department. And it was the old-time animal husbandry with a lot of judging and that sort of thing.
Mm-hmm. What sort of pigs were they? What breeds in those?
Well, I don't know. They had Chester Whites, I think, was the main breed they had there.
Yeah.
But it was at the time when they still had a herd of Percherons and a herd of Belgian horses, Holsteins in the dairy, Angus and Shorthorn in the beef barn.
Right.
I forget what sheep they had. But for anyone who was interested in livestock at that time, it was a great place. One of the professors that taught animal breeding was a veterinarian, Karl Gay, and he'd been chairman of that department for 20 years, and he just stepped down the year that I got there. And he was the one that I really remember. But I was interested in animal breeding and genetics once I got into animal husbandry. And at that time, nutrition was the only aspect that was getting much support in the way of research. The young fair-haired man in the department, the PhD man, was Thomas Scott Sutton, who went on to do greater things. And they just didn't have any emphasis on animal breeding. So I suppose that's why I became a little disenchanted about continuing there. And I'm not quite sure how I got into veterinary medicine, but after, well, I think I was somewhere about the, must have been the second quarter junior in animal husbandry, I decided to switch into veterinary medicine. And I remember going to see the dean of the veterinary college at the time, old Oscar V. Brumley, sitting there smoking a cigar, a portly man, and he dissuaded me. You know, Hadlow, what do you want to come into veterinary medicine for? Stay in animal husbandry. And I got the same story from, I think he was probably the secretary of the College of Agriculture. Stay in agriculture and animal husbandry. You don't want to go to veterinary medicine. By today's standard, I would never have been accepted. You know, I didn't have that much in my background to qualify me. But with what I did have, about almost 3 years in animal husbandry, I was accepted in veterinary medicine. That was in June of 1942. And it seems like an odd date, but they'd been going year-round during the war. Oh, okay. So the year started in June in 1942 anyway. So I went through that, and of course this was during the war, and I had gotten a deferment from a draft board in Cleveland, Ohio. And then the Army came along with this Army Specialized Training Corps, ASTP. And there were 3 companies at Ohio State: veterinary, dental, and medical. You wore an Army uniform, marched to class, lived in, not really barracks, I think we lived in a girls' dormitory, or what had been a girls' dormitory, and that went on for a year. Weekends you were in calisthenics or something like that. You were in the Army. And then they decided to disband that whole program, and the first company to go was the veterinary. Well, you had 2 choices. One is you could stay in the Army and probably be transferred to the infantry, or you could take a discharge and go back to your draft board. Well, I didn't think I'd stand much of a chance with my draft board, with the reputation I heard about it, and they'd already given me a deferment. So 2 of us, myself and a classmate, took the discharge. It was something like 6 o'clock in the afternoon, took an overnight train to Cleveland, enlisted in the Navy the next morning at 9 o'clock. Then 2 weeks later we came back to be shipped somewhere, didn't know where. Anyway, I wound up at Camp Sampson in Lake Seneca, New York, for boot camp. And I was considerably older than most of the recruits. I thought were really kids. So I went through that. And when we enlisted, my classmate and I asked if we could get into the hospital corps. Well, they said we could, but you didn't know that that might really happen. But lo and behold, after boot camp, we were sent to San Diego, California, at Balboa Park for hospital corps school. So I went through that. And it must have been sometime in the fall of 1944. And then I'd ask for sea duty. Well, I didn't get sea duty. The next thing I knew, I was on a train going to Jacksonville, Florida, the Naval Air Station Hospital. And I had ward duty there as a corpsman. I was still a, I don't know what they called them, hospital apprentice, I think, a little cross, before I got my first stripe. I never made it beyond a third-class pharmacist mate. So that's how I spent my career. Well, I did duty there, mainly
how long did that
night
last?
duty. I don't know how long I was there.
Weeks, months?
Oh, it was months.
Months.
Yeah. Ward duty on an orthopedic ward, night duty. And that was all right. And did a few other things there. And then, I'm not sure whether I requested it or whether it happened, just happened. I was sent here to the National Naval Medical Center to lab tech school. And that wasn't really a challenge. The emphasis there, as I remember it, was on malaria. You had to know how to diagnose malaria from blood smears, some hematologic work, and a lot of parasites out of the gut, especially amoeba. Well, then, the next thing I knew, I was sent off to Great Lakes Naval Training Center. They put me in charge of a big serology lab. And most of the help there were just sailors. But the thing was in chaos when I got there. It was a lab to do the presumptive contest for syphilis. And it was at this time that a lot of the Navy and Marine people were getting out of the service, so they had to be checked out. We had 2 shifts doing this test. Well, that was all right. And then you were getting out on the basis of how many points you had. And I had acquired enough points to be eligible to be discharged, but I was declared essential running this serology lab so everybody else could get out clean. And then I finally was discharged, I think it was April 18th in 1946. Went back to Ohio and went to work with a veterinarian who had just established a practice in Medina, Ohio. He was a recent graduate of the Ohio State University. I just knew him vaguely. He was about 2 classes ahead of my original class. And so I worked with him. I probably got a little ahead of my story in that, well, no, that was it. I went to Medina, worked with him. We did TB testing of cattle, and it was a general practice. A lot of dairy cattle in that county, and he was running an artificial insemination program. So I took that over, and
had you had training in that, or did he
no,
train you?
No, I didn't have training. That was interesting. You know, the first time you were up the dirt road, things were unfamiliar. But and it was in those days. This was 50 years ago.
Right.
You made your own glass tubes. You didn't have straws. You used the syringe. Got the semen from the post office a couple times a week. I think we had 5 or 6 bulls, little vials. Remember that yellow stuff? They used egg yolk as a buffer, you know. And anyway, did 15, 20 cows 7 days a week for 8 or 9 months. It was a good experience. But they always accused me when I came back to school that I came back in this kind of a position. You know? Well, anyway, it was a good experience. I had to do that because I couldn't get back to into the proper sequence of the classes. I had to wait almost a year.
Were they still on the year-round thing, or are they stopped?
Yes, well, I'm not sure whether, I think they were at the tail end of that. Anyway, I had to wait until January of 1947 to finish the third quarter of the junior year. Then I started the senior year, that spring quarter. Yeah, that was the winter quarter, then the spring quarter. And then I went to work with John McAuliffe in Cortland, New York.
Yeah, this is when, after graduation?
No, this was that first summer. It was the summer of 1947.
Okay.
There was a fellow there, a veterinarian from Cornell, who was taking some graduate work in the clinics. And I was living in the clinic at the time, which was a good experience too. I was still, well, when I first went to the clinic, I was a junior, but we were the senior veterinary students there and got a lot of obstetrical practice. These were it was in a day when cesarean section wasn't resorted to. Any cases of dystocia dealt with by embryotomy, so we cut out a lot of calves.
So what actually happened? You would get called out, you would go out on your own?
They would bring the animals into the clinic at night.
And did the veterinarian come, or did you you handled them?
The ambulatory veterinarian or a large animal veterinarian who was supposed to be on duty turned it over to us, unless you had real problems. And you usually had some real problems. I remember cutting up some of these schistosoma reflexa calves. Anyway, this veterinarian from Cornell arranged this. When I had an interest in dairy cattle, I was going to go into dairy cattle practice, and he arranged for me to go to work with John McAuliffe at Cortland, New York, just north of Ithaca, and that was great. This was a dairy practice, and John McAuliffe was a great man to work with. The one herd had 750 Guernsey cows. These were, so I had a lot of experience. I certainly had a lot of experience lifting hind feet of cattle to treat fowl in the foot, which was rampant in those days. Well, anyway.
So there was that, and what other sort of conditions were
the usual,
common then?
Milk fever and ketose, acetonemia, a lot of mastitis and teat problems. They were always working it. And the usual thing, retained placentas and that sort of thing around dairy cattle. Well, that was a good experience. So then in the fall of 1947, went back to Ohio State to complete my senior year, which I did, completed it in March of 1948. Well, all during that period, my intention was to go into dairy cattle practice, probably up with John McAuliffe. And I don't recall the details, but Jay Sauter from the University of Minnesota had written me earlier in 1948.
He was the head of the pest department there, right?
They just started a veterinary college in 1947, and he was looking for someone to help him put together a department of veterinary pathology. Would I come up, or would I be interested in coming up and helping him? And as I say, I don't recall why I decided to do that. I much disappointed poor old John McAuliffe, and I'm not sure whether it was the right decision or not, but anyway, it worked out there. I went to Minnesota in April of 1948, ostensibly to help him put together a department, the materials for a department of veterinary pathology so he could teach sophomores, and to do graduate work. It was a great place for veterinarians to do graduate work, simply because you had access to the basic science departments at the medical school. There was great rapport and good liaison between the two before they had established the veterinary college, when it was still a department of veterinary medicine. It was still a good place for graduate study. Well, the man who was directing the graduate students there was not a veterinarian. I don't think he had a real understanding of pathology, but once I got there, I became interested in pathology, which, by the way, was probably my worst course in vet school, pathology. But anyway, I went there and helped put slide boxes together. And with one of the students, there were only about 20 students in that first class, mounted a lot of specimens. In those days, the pickled specimens in the museum was all part of the training. And we used to get these cans full of offal from South St. Paul packing plant. And you'd muck through that and find out something that was decent to mount on glass frames in these big jars. So I did that. But as far as the graduate study, I tended to feel I was going to be shoehorned into pharmacology or physiology, and I wasn't interested in that. So I balked a little bit and decided to, I was an instructor at the time in the veterinary college. And I said, well, this wasn't going to work out. So anyway, I still had a bailiwick over in the veterinary college, and I had access to the post-mortem room and that sort of thing. But I wasn't helping teaching any longer as an instructor. So I went over to the medical school.
So what actually happened? You left the staff of the officially of the veterinary school?
On paper, I left the staff, but I had space there.
But your pay stopped, did it?
The pay stopped, yes.
And so you managed to live by...
I was working on, I think maybe my GI Bill had run out by then. And I'd gotten a fellowship from the American Veterinary Medical Association. It was a rather modest stipend. I can't remember what it was, but it wasn't much. And anyway, I went over to the medical school. But there was had been some liaison there earlier because others had gone over there, including Jay Sauter, to take some of the courses in the department. And Dr. Alexis Thomas Bell, or Tom Bell to everybody that knew him more casually, was a professor of pathology. He was an old man, a big man. When I went to see him this morning, he was sitting behind his microscope, one of those great big tall ones, smoking a cigar. He gave me about 5 minutes to make my proposal, and between puffs on the cigar, he said it was okay, Hadlow, you could come in. All you had to do was take my sophomore class in pathology, and then you were free to take anything else in the department. So that's what I did. And so I was dumped in with about 125, I think, medical students, mostly men. And we taught the sophomore pathology course. He used his book, which was a textbook of pathology, 6th edition, revised, enlarged, 910 pages, 500 illustrations, 4 color plates, published by Lee Fibiger in 1947, cost $10. And he lectured essentially verbatim out of his book. So there wasn't any need to take notes. Occasionally there was a nugget you'd have to write in the margin of the page with a fountain pen, didn't have Bics. And you did a lot of underlining, didn't have the yellow highlighters, and that was it. Well, that was great. It was
So
great.
how much of the book did he actually...
Covered the whole book.
900 pages?
Well, you might have, gone fairly rapidly over some of it, but you had to know the whole thing.
In what period of time was that? A year, was it? Or
It was a year.
3...
Sitting in this old amphitheater of Millard Hall. Well, I don't want to get out of sequence, but this was the last class he taught. And so the last lecture, the class had gotten together, and he was a great cigar smoker. I can't remember the brand. I'm sure it wasn't a cheap one. They gave him a box of cigars. And one of his contemporaries, Ben Clausen, who was going to retire at the same time, he had written a chapter on cardiovascular heart diseases for Bell's book. He was there, and he was a non-smoker, so he got a basket of fresh fruit. Well, in addition to that, each got a hand-painted tie, and at that time, I think it was a common practice to have a hand-painted tie with some kind of illustration on it. So for Dr. Bell, they had the usual, in those days, round microscopic field, and it was a chemostyle Wilson nodule of diabetes. His interest was in diabetes and renal disease. And for Ben Clausen, a kindly old gentleman. His interest was heart. He had a similar round microscopic field with an ash-off nodule of rheumatic fever. Well, then Bell passed his cigars around to the students. He lit up. A few of us lit up in class. And I remember the last lecture that he gave in this blue-gray smoke of cigar from cigars. We're sitting there smoking cigars. You know, talk about a change in times. Well, anyway, you either smoked a cigar or a pipe in those days.
Just one thing, how did you just tell us something about you as a veterinary student, probably older than some of those people, fitting into a medical class?
That was, you know, I never really felt out of place. Once I took this course, as I said, everything else, I was free to take anything else in the way of graduate courses in the department. I hadn't realized at the time what that meant. I was dumped in with about 4 or 5 MD residents in pathology. And you were expected to fit in. I never felt out of place. They were a good bunch. The fact that I was a veterinarian with a, you know, somewhat different background, I was welcome. I didn't have a lot of individual take with Dr. Bell, but I did with some of the other members of the department. And so I was made to feel at home. Well, it meant that you had to do everything. Took my turn blocking tissues that were sent in, and you would.
Well, I'll tell you one thing which would be interesting to, I think, to to all of us would be if you.
How much do I have to read?
Well, one thing that would be very interesting, I think, to all of us would be how well you felt prepared from, first of all, the Ohio State experience. I'm sure the hospital experience in the Navy must have actually provided a lot of background where you felt comfortable, so you didn't go in there sort of as a naked.
No, not really. You know, at one time, I suppose a number of us, when we were in veterinary college, and perhaps after we'd taken a course in pathology and learned something about what disease actually is, became interested in human medicine. And I had kept that in the back of my mind. Well, after this experience in the Navy, dealing with sick people, I concluded that that wasn't where I wanted to spend my time.
But you had seen a lot that gave you a background, so that when you did this pathology course...
oh, yes, yeah. And then, of course, back in those days, there was only one book on veterinary pathology, a Runnels book.
Yeah.
And for some reason, it wasn't prescribed for our course in pathology that we received at Ohio State. There was one other in English. It was a British one, the Gager and Davis, and that had half microbiology and half pathology. Unless you could read German, the good books were in German.
Right, Liebele course.
So we used, or often as a reference, used human pathologies. Karstner, Boyd, and then Anderson came along. So you were familiar. I think as veterinary students, you were more familiar with human disease from the standpoint of pathology than the medical students were of animal disease. You know, they didn't have any idea that there was such a thing. So I didn't feel too out of place. Remember, first autopsies, you had to adjust to that. But at that time, all the, as they call them, autopsies or necropsies, in the Twin Cities were funneled into the Department of Pathology at the medical school. And and there were very few pathologists. So you'd go out with one of the residents to some outlying hospital in some cold mortuary basement room to do the necropsy. And Usually they sent out not the real pathology, the residents in pathology, but fellows that had come through there for maybe 6 months. There might have been pediatricians or radiologists or whatnot, internists. But they had to do necropsies as well. And you'd go out with them. And you got a chance to do everything, you know, even taking brains out.
Mm-hmm.
And so that was good experience. In those days, anatomical pathology was emphasized. And one example of that is everyone just happened to have a slide in their pocket or up their sleeve. This sort of quasi-sleight of hand was one indication of the emphasis they put on anatomical pathology. And when you looked at the slide, they didn't expect you to comment on the clarity of the staining or the color or the freedom of artifact. What's the diagnosis? And anything was fair game, any tissue or any organ. Well, that was good experience. You had to be on your toes all the time.
Mm-hmm.
And of course, this was human stuff. And I had to learn a lot in a hurry. But having had the pathology course, the sophomore pathology course, and then with my other background,
Mm-hmm.
it wasn't too difficult to make the adjustment.
Actually, in that course, did he have a lot of illustrations?
Didn't have anything that was projected the way they do now. There were illustrations, these 500 illustrations in the book is all you had. You did put a lot of emphasis on the gross aspects by going to the museum. And that's where Ben Clausen, that I mentioned earlier, who retired with Dr. Bell, used to be found wandering through there. And he was a great old man to talk with. He felt a special closeness to veterinarians because in the early days he had worked at a hog collar antiserum plant in Missouri, I think, doing some of the microbiological work,
Mm-hmm.
and he worked with veterinarians. So he was a great old man. Another one in the department was Jim Mccartney. He was a pathologist of the old school, wasn't quite as old as Dr. Bell and Dr. Clausen. He sat on a stool in front of his microscope and without a mechanical stage. You'd bring a slide to him and you always got an immediate opinion as he moved it across freehand.
Mm-hmm.
And yeah, his interest was liver disease.
Mm-hmm.
And then another fellow in the department who was really the youngest man in the department. He'd just gotten his PhD. He worked on gastritis and gastric ulcer, Bob Hebel. He's a tall man, wore a long white coat, smoked a full curved pipe, so he couldn't have been all that bad, you know. And when he barked, even the senior resident responded, and mostly out of respect. Well, he was in charge of, and he had quite a practice, cutting up or examining all the sentients. You know, they were surgicals,
Mm-hmm.
some were necropsy specimens, and I had to take my turn cutting them in. He sat to the person's left,
Mm-hmm.
you know, while you were cutting it up, and taking his notes, and then all the residents were on the other side of this table.
So just mention about that. When the specimens came, you did give a description and measure them, and
Had to do all that.
and was it dictated to somebody, or did you write it down,
He
or
was
somebody?
taking notes.
Oh, so
Didn't have any.
no, but you
I made the description.
You made the description, so essentially your major advisor is writing it down.
That's right.
Yeah, that'd be rather
Well,
over powering, wouldn't
well,
it?
he probably edited it as he was writing it down, and yeah, that's the way it went. And in those days, it was gallbladders with a lot of rocks in them,
Mm-hmm.
inflamed appendices,
Mm-hmm.
great big one, uterine curettings,
Mm-hmm.
endometrial curettings, and what we call prostatic chips from transurethral resections. And they're probably hysterectomy specimens, usually with multiple fibroids.
Mm-hmm.
Some partial gastrectomy specimens.
Yeah, that was popular.
And in those days, they did a lot of mastectomies
Uh-huh.
with a complete axillary appendage. And so you had to get used to all that stuff. And that was it was a good experience. I wish I'd spent more time with Bob Hebel. I used to see him after I left there. He used to come out to Montana to fish. And on a number of occasions when I went back to Minnesota after I had gone to Montana, I'd always stop in to see him. And we'd go to the faculty club for lunch. It was great. Well, I don't want to prolong this bit at medical school, but as I say, I was welcome.
So this was for how long now, the total period?
A little over 3 years.
Okay.
And well, there are a couple of other little incidents that are of interest.
You were enrolled in a program at the time?
And I was in a PhD graduate program. And when Dr. Bell left, he was replaced by James Dawson from Vanderbilt University. He'd been a student of Ernest Goodpasture, and he had a research background. Otherwise, there wasn't any experimental work being done in the Department of Pathology. Didn't have funds. It was the days before really the grants and all that. But when Dawson came up, he tried to do a little. And I remember he had a few rats around there that he was doing something on. But he was known from Dawson's encephalitis, the old, what they determined later was caused by the measles virus, subacute sclerosing panencephalitis. 3 to 10 years after measles, these kids would come down with chronic neurologic disease. And he was even more receptive to my being there. And we had more of a one-to-one give and take than I ever had with Dr. Bell. And he tried to encourage me to go on and get a medical degree. Well, I wasn't really interested in that. As I mentioned earlier, I'd gotten that pretty much out of mind. I was going to be an animal, be a veterinarian in animal pathology. I remember when talking about earlier about the cigar smoke, Friday afternoons, right after lunch, they had the clinical pathology conference, and a handful of pathologists from the Twin Cities were there. Most of them were young men, and then all the residents in the department, and they would show their cases. And these glass slides were projected by one of those old carbon arcs, and a great big whistling machine, and there was only one big Scandinavian woman that could make that thing work. Well, she'd get that cranked up, whistling, and you project the slide. Well, I projected, I brought over a few, and you'd have to give a little history. Well, maybe I withheld the fact that it was from a cow, but it was a granulosa cell tumor with all the good Karl Eklund bodies, and they muffed it. I don't know why. But I remember I sat toward the back of the room, and Dr. Bell sat up front. He had the last word on all the diagnoses that were presented. But all the time I took part in this, I saw the projected images from those slides through a cloud of blue-gray cigar smoke. He was up front smoking his postprandial cigar. Well, that was great. And so there was a great emphasis on anatomical pathology. You had to be on your toes. And I suppose I've forgotten most of the human pathology, the incidentals. But what I really got from my experience there was that the detail, when you do a necropsy, and you look at everything microscopically, regardless of what bearing it might have had on the cause of death or the final diagnosis.
So how many slides did they cut in from a average?
Oh, I don't know. There was a pile
30,
of them.
40, 50?
Oh, it was probably 30 anyway. You remember you looked at everything. Someone always asked, well, what did the adrenal look like, just for the hell of it? As far as neuropathology, in those days, we always used to say that in the Department of Pathology, we dealt with bodies without heads. Because the brains, we took the brains out, but the brain went to the Department of Neurology and Psychiatry, which was run by A.B. Baker. I think he was essentially a clinical neurologist. And I wanted to learn more about neuropathology. Actually, my first exposure to the marvels of the nervous system came when I was still over at the veterinary college at St. Paul. This was sometime in 1949. Well, I used to still get back there. And a fellow came there, Calvin Turbies. He's still around. I think he's at Creighton University in Omaha. He was a walking encyclopedia, and his discipline was neuroanatomy. And in those days, that was one academic discipline that received a lot of attention. Andrew Rasmussen over in the medical school taught this course in neuroanatomy, human neuroanatomy. And one of his students was Ralph Kitchell, who made a great name for himself as a veterinary neuropathologist. Well, Cal Turbies was forever cutting up dog brains or some brains. I used to watch him, and one morning I spent more time there and showed me how to cut up a dog brain properly and identify the main structures, and we talked about what might happen if the structure were damaged. And that was, I suppose, my first exposure to something having to do with diseases of the brain.
So
but I needed to know more neuroanatomy.
So you didn't get this in the routine service work that you were talking about at the
Well, that came
school.
later, yeah. So I took the course in neuroanatomy under O. Rasmussen. And it was a course you never really flunked. You know, you took it over. And he had gave a lecture with great enthusiasm, and then had these wonderful labs with a lot of demonstration. And he always tried to impress the student with the fact that, you know, that was from a real person. It's not a diagram. That's an actual nerve cell or whatever it was. And then we had to dissect a human brain. Well, I remember dissecting mine with one of the residents in pathology, you know, already an MD, but he needed to know more neuroanatomy. So that was a good experience. But then as far as, you know, neuropathology, since it wasn't dealt with in the Department of Pathology at the medical school, had to go over to neurology and psychiatry, where A.B. Baker held forth. Well, when I wanted to take the course, which was taught from his little softback book, Outlines of Neuropathology, he was doing the clinical rounds. So his junior associate, Fay Tishy, was teaching the course. It's a very practical course, and as was most things in those days, it was directed toward making a diagnosis. And so it was a good practical course. Took that was, you know, lecture course. Well, the brains that went over there, that we sent over from the Department of Pathology, or other brains that came in, they were cut up on a Thursday morning.
Yeah, what was the policy there? How, you know, there's been some difference in how long human brains are fixed and before they're sliced, and anything from, frankly, I've seen people cut them from a week to 4 weeks.
I can't recall.
Were they completely bleached?
Most of those that I saw were, and how long they'd been sitting in formalin, I don't know. And most of them were, you know, whole brains. They might have been severed through the brain stem somewhere.
Were they bleached completely?
When you cut down in them.
Or were you able to see some of the color differences?
Oh, occasionally you could see a few pink areas.
Okay, so they'd fixed them for a long time.
Yeah. I don't know how long it was, but anyway, the brains were cut up on Thursday. And then on Tuesday afternoon, you looked at the sections.
Okay.
Well, I took advantage of the tutelage I got from Fay Tishy, who taught the course and did this part of it, cut up the brains and so forth. She spent hours with me at a microscope going over these slides. And it gave me the necessary background.
That's wonderful.
To make some sense out of what I was seeing in the human brain, and then later in animal nervous tissue. So that was a great experience.
Did they have standardized sites in those days to sample human brains?
They did, and I can't.
No, but there was a chart up in the above where you sliced it. Yeah.
She did all the slicing, and it was done, you know, precise. So they took the prescribed levels and whatnot.
Right.
Yeah, and I never was too good at tumors, but it was fun doing the other parts. And so it was good experience.
Okay.
That sort of wraps up my exposure to pathology at the medical school.
Yeah.
So
The one thing you really haven't brought out is you'd been there these years and you'd got this wonderful experience and so on. What sort of brought it to how did you know that the end had come, or that you weren't going to do more there, or get a higher degree, or what actually precipitated things to...
I couldn't see where I had a decent dissertation subject.
Okay.
There wasn't any support. My stipend from the AVMA was running out.
Well, actually, then on that basis, the medical school essentially got some labor.
Oh yes,
Free.
they didn't put out any money to when I was there.
Okay.
That's the way it was.
Well, why don't you tell us in the time that we have left for this session, just briefly what happened,
Well,
how you left, and ended up at...
given this situation, I wasn't certain what the end would be after I'd spent about 3 years there. I should have stayed longer, but George Young, who was at the Hormel Institute in Austin, Minnesota, and the Hormel Institute was financed by the Hormel company, the meat packing company, but it was part of the graduate school. And George was working on transmissible gastroenteritis of piglets. And he had convinced me to come down there and do the pathology. Well, it turned out to be a complete bust. I had to cut my own sections. I necropsied a heck of a lot of pigs. And the only pleasant thing, I suppose, about the whole experience down there, I met the young lady who became my wife. So I became disenchanted with the work there. And then when this opportunity came up to go to Hamilton, Montana, I seized upon that.
And that came to your notice how?
Up another whole story.
How did that come to your notice?
Karl Eklund,
Yeah.
one of the MDs out at, virologists out at Rocky Mountain Laboratory in Hamilton, Montana, used to stop by the veterinary college at St. Paul, and just to see what was going on the veterinary side, and I had met him there. And then when they were looking for a pathologist for the Rocky Mountain Laboratory, someone who would, I guess, replace the MD pathologist who had been there and had left 18 months earlier, they had to fill the slot or lose it. And in the interim, they decided a veterinary pathologist was what they wanted. So he wrote to me, but I happened to be in Austin, Minnesota at the time. The letter got to me, and we got the correspondence going, and I accepted the position.
Did you go out and have a look at the place?
No, I didn't. I didn't even know where Montana was, and I had very little understanding of what Rocky Mountain Lab was, but it was out there in the boondocks in Montana. And anyway, in June 15th, 1952, I rolled into Hamilton, Montana after borrowing, I don't know, a few $100s from my wife. We were just married a few weeks earlier, to buy gasoline to drive out. And that opened another whole story in my career out there. It was entirely different. You know, I was still pretty, well, I was quite green yet, and dumped in with this group. But it gave rise to an interesting career.
Well, it's been great to hear about this first part of your experience, and the wonderful opportunities to be so well trained in this background in pathology and neuropathology, and now you're going to move to Rocky Mountain.
And something a little different.
That'll be the next phase.
That's
We'll
right.
hear more about the scrapie and so on.
That's right. All
Well,
right.
thank you very much for that. Well, Dr. Hadlow, you sort of given us an introduction into how you at least got to Rocky Mountain Laboratory. Could you fill us in now on sort of what you found there and how you sort of worked out how your career was going to progress from there?
Well, as I mentioned, I rolled in there June 15th, 1952. Not really certain what I was getting into. The Rocky Mountain Laboratory was established there many years ago from the work of Howard K. Ricketts when he came out from the University of Chicago to study Rocky Mountain spotted fever, which was endemic in the area and a big concern to the people there. In 1930, they established the lab that at the site where it was when I got there. And then it sort of grew like Topsy. There were about 5 buildings that made up this complex. It was on the edge of the town of Hamilton. And the main research thrust, it was part of the National Institutes of Health. They had taken it over about 1930, when the state could no longer handle it as a state institution. And at that time it was part of the National Microbiological Institute, which is now the National Institute of Allergy and Infectious Diseases. So the work was on infectious diseases, and especially so-called diseases of nature transmissible to man. So I was exposed to all sorts of diseases such as tularemia, plague, Rocky Mountain spotted fever, Colorado tick fever.
So which animals were these in?
Well, I was there as the pathologist.
Yeah.
I was put in a section called the Section of Serology and Pathology under a serologist who was very helpful. He took me under his wing. As I say, I was pretty green when I went out there. There was still a histology lab, and they had all been waiting for someone to come out to look at all the material they had. And since they did a lot of field work, there was always a lot of things brought in. And they had this great contact with game biologists, people in the field who would bring in specimens. So it was sort of overwhelming for someone coming from the background I had and from just coming from almost solely human material to all this animal material.
And what sort of animals were there? You mentioned that you had field materials.
Yeah, a lot of it was, the wild animals would be field rodents, beaver, muskrats, and skunks, coyotes. When I got there, they still had a bull elk in one of the pens there. Well, it was that sort of thing, and then they were working on a number of diseases in the lab, and so there was the guinea pig material and rabbit material, in addition to all the rest.
This must be a bit overwhelming, mustn't it?
It was, but it was, a lot of these were just names to me, but I began to see what sort of lesions were associated with these diseases, and so that was fun. Then I got in on, the group out there was made up of, there were, I think, 3 or 4 other veterinarians who were just there temporarily. They were working out of CDC, which was the Communicable Disease Center at the time. And they were all in the commission corps of the Public Health Service, as were most of the MDs. And the others were PhDs, usually in microbiology or biochemistry, that sort of thing. So that made up the staff. There was a little turnover in the staff, so there was a certain stability there, and had a sort of a familial atmosphere. Everyone knew one another by first name. It isn't that way now, but that's the way it was then. So it was a very pleasant group to be part of.
What was the sort of life like out there in that little town? I mean, economically, other interests. What was your first reaction and your wife's reaction?
It's rural based,
yeah.
in the Bitterroot Valley. It's agricultural, more so then than it is now. The town was probably 2,500 population, and apart from the Rocky Mountain Laboratory, a federal institution, and the office of the Bitterroot National Forest, another federal agency, there was little going on. It was, if you weren't a rancher or your father or family didn't have a store uptown, there wasn't much for you to do. And socially, because of this familial atmosphere at the lab, that was the sort of social circle you had. I found it very pleasant. Most people found it a little too isolated. But the beautiful Bitterroot Mountains behind the lab, you couldn't avoid becoming attracted by those. Climate was beautiful, not like most of Montana. When people hear you're going to Montana, they feel sorry for you. Well, that's eastern 2/3 of Montana. The high plains, the weather is quite different. Very pleasant and moderate in Hamilton. There were a number of projects that I became involved in as a pathologist. Not always at second thought, the way it always happens. After the experiments done, animal experiments done, got some stuff they want you to look at. I worked with Karl Reinhardt on leptospirosis in cattle. That was an important infectious disease those days. Leptospira pomona, it was called then. Did some experimental work and looked at some material from naturally infected cows.
How was that manifest out in the cattle on the range? What was the major worry there? Was it?
I'm not sure about the clinical picture. I didn't have anything to deal with that at the time.
How did they pick that up?
Well, I think it was. They probably had some abortions.
Okay.
Other than that, I'm not sure what the clinical problem was presented by the infection.
So was the experimental work on?
The experimental work was done on cattle, and it was...
Pregnant cattle?
No, these were young animals, mainly to determine something about the pattern of the infection, how the spirochete moved around, and how it was shed, and the chronology of all this, and then what lesions it gave rise to. It wasn't a big project. Another project that I became involved in, apart from all the other things I was looking at, it was a heyday for a young pathologist someone who wanted to be a good general pathologist, saw all kinds of things that I probably wouldn't have seen elsewhere in a strictly veterinary environment. It was a project on salmon poisoning of dogs, a most interesting disease caused by a rickettsia, in which the fluke is the vector. Poor dogs become infected by eating the fish that are infested with the fluke, and that's the whole story. But the disease in the dog is quite interesting. Did some of that. Unfortunately, the only thing I ever published on that had to do with the neuropathologic changes. Still haven't dealt with all the other interesting changes, the essential changes in the viscera. And then some of the group were working on yellow fever in rhesus monkeys. And I wasn't really part of the project, but I had access to the monkeys, and I did a lot of necropsies on monkeys that were dying of yellow fever, just out of general interest.
Do they have good facilities for autopsying?
Well, when I came, they did have the histology lab, but they didn't have a necropsy lab that I would call. You do it on the end of a bench or something.
So even these zoonotic diseases got handled?
Yeah. Well, it was fairly relaxed, unfortunately. And I came down with spotted fever as a result of my own clumsiness. And the next spring I came down with endemic typhus because of somebody else's clumsiness. But it was that sort of thing. But I posed this to the director, who was an MD, Karl Larson, grand fellow. I needed a necropsy room, and as it turned out, they turned his animal room into a necropsy room for me. Well, that's pretty great, before I really got the better one. But at least I could handle even a cow in that room. And so I was all set then. That's where I did all the necropsies on these monkeys. Then, well, I'd gotten into some work with Coxsackie. They had a community health project, examining stools brought in, human stools brought in, for some of the enteroviruses. And the procedure was to inoculate both tissue culture and suckling mice. And the Coxsackie viruses would do something to these baby mice. And I looked at a lot of those because at that time you could separate the group A from the group B Coxsackie viruses by what they did in the baby mice. And I had a way of cutting complete cross-sections of these baby mice, about 7 cross-sections. You got essentially all the organs of the mouse. Did that, did a little work on Coxsackie in rabbits, and that was published. And then in the spring of 1952, when Salk polio vaccine was first used, they found that after it was used on children in Idaho, some of them came down with paralytic polio. And Karl Eklund, an MD pathologist I'd mentioned earlier, and I'd done some work with on Colorado tick fever in mice, went down there and investigated it, collected specimens. Indeed, that's what had happened, ostensibly. They were vaccinated, they came down with paralytic polio, and sometimes even the parents. So obviously they were shedding virulent virus. Well, Eklund and I worked on this, and we demonstrated actually live polio virus in the Salk vaccine, that particular batch anyway, by inoculating rhesus monkeys directly into the spinal cord. That wasn't the route they used in their primate safety test. I think it was inoculated intracerebrally. So I had a chance to see a lot of polio in monkeys, and necropsied a lot of monkeys in those days, just looking for lesions. Well, someone decided that I needed to know more about the pathology of polio in monkeys, because when they were doing the safety test, it had to be done when you looked at the central nervous system of these monkeys that were used in the safety test. There was a prescribed protocol for examining the brain, thickness of the section, the stain you use, the levels, and so forth. Well, maybe I didn't do that quite in that way for my own purpose. But someone thought I should go back and learn this. So in the fall of 1955, that fall, after we'd done this work on the vaccine in the monkeys, went back to NIH and worked with Dr. Llewellyn Ashburn. He was an MD pathologist, grand fellow, one of the senior pathologists in the National Institutes of Health at the time, worked under Ralph Lilly, who was the head of pathology for NIH for a long time. And Lou Ashburn was in the Institute of Arthritis and Metabolic Diseases, I think it was called at that time. Anyway, after I talked to him, he says, "Hell, Bill, you had enough experience with polio, the pathology of polio in monkeys. You don't have to look at stuff here." So he turned me loose doing essentially the same thing that I did at Minnesota. He was working on all the sentients from the marine hospitals and the Indian Health Service. So there again, I was back looking at gallbladders, appendices, and wedges and ellipses of skin and whatnot. And you were turned loose. You had to make the description, write up the microscopic findings, and then take it to him and review it with him, and he'd sign off on it. Well, he was taking a big risk, I think, with someone like me, but he's a grand fellow. And I spent 3 months with him doing that. And fortunately, the MDs, young MD pathologists that were working under him, were another great bunch to work with. So that was a most enjoyable time. I could have spent a lot of time there. And then I came to AFIP, and that was been the first part of 1956.
So you left NIH?
I left NIH. My wife and I were living back here in Bethesda, and went to AFIP. I used to ride in with Carl Jones.
Actually, how was that arranged? Was that officially an official?
It was officially
posting
arranged, yes.
To do ostensibly, or
well, since I was working for the government, for the Public Health Service, they had some official arrangement whereby I could do this, since it didn't cost AFIP anything, and I was welcomed. And I spent a month with Webb Haymaker in neuropathology. Well, he was disappointed because He was quite enthusiastic about my joining him, but he thought I was coming for a year, which would have been great. But then he wasn't there very often. And there was a Navy captain, a pathologist. I don't remember his last name, Bill. He looked like Charles Lawton physically. And he was a good practical neuropathologist, and I learned a lot from him. And then after that month, I went to the veterinary pathology department, where Carl Jones was still head, and had a pleasant month there. Chet Gleiser was there, and Fred Maurer, Charlie Barron, and that crew of that vintage. It just wasn't adequate exposure to veterinary pathology here. See, I wanted to be a veterinary pathologist, but my background is quite uncommon that way. When I got out of school, if you were interested in veterinary pathology, where were you going to go? There were, I don't know, very many places where you could go and get good solid training. It was just more of the same old stuff. And in the end, the only place that I'd ever heard about was Cornell University under Peter Olofsson. Well, I didn't know about that at the time. Anyway, I wound up in Minnesota and got my training in human pathology. Well, after I left AFIP in the spring of 1956, went back to Rocky Mountain Lab, continued my work there.
Just tell us a little bit. You've been away for a few months. You roll up back there. Projects are going on all the time. Was it, when you got back, was it one of those experiences that you wondered, was the stuff piled up?
Not, well, some of it was, but not really. They knew I was going to be back. So I would have been away, at least 5 or 6 months.
Really?
And I had a good lab tech, a fellow that I trained. He was with me 20 years. He came to me shortly after I arrived there. The technician who had been there left. And he was a native boy that had no formal training. And he pleased me, I suppose, over the years because he did it my way. That's the only way he knew. And so that worked out fine. And he looked after things while I was away, kept things going. Anyway, I returned and continued doing work there. Then it was in along about the spring of '57, I received a letter from the Department of Agriculture wanting to know whether I'd be interested in taking a 2-year stint in the United Kingdom, Scotland or England, to work on scrapie. Scrapie had appeared in this country. It was an exotic disease. They were interested in working on it, but they didn't want to do it in this country, but they would send somebody over to Britain. And well, I thought about it. I became a little restive, I suppose, out at Hamilton. I didn't, to start, choose to join the Commission Corps, the Veterinary Corps of the U.S. Public Health Service Commission Corps. So I was still civil service, and because I wasn't certain I wanted to make my career there. Well, I think I was the last name on their list. They had so many turndowns. So in the end, Hadlow says yes, he'd take this offer. So my wife and I packed up everything and moved to England in April of 1958. And that was another whole experience. The USDA had put an embargo on British sheep in 1952, I think it was, because that was the source of scrapie in North America, Canada, and United States. And this gave rise to a renewed interest in scrapie in Britain after a lull during World War II. And so there were two groups, one up at Edinburgh, Scotland, at the Morden Institute, and the other one in England at Compton in Berkshire, west of London, at what was called at that time the Animal, I forget what it was called. It was a field station of the Animal Research Council field station. It was about a 250-acre estate. had great facilities for handling animals, a big isolation compound, and they did a lot of work on scrapie. That's where I was destined to spend 3 years. And the lab at Compton was run by a hardy Scotsman, William Smith Gordon, great fellow to deal with, a real gentleman. And he made life for my wife and I the most pleasant as he could there. Because there, as you probably realize, was a big cultural adjustment. Well, we got over that, and we found a place to live right on the estate in the old manor house. I went back 400 years, I guess. And they gave me a bailiwick in a building called the Pigeon House. I think they had to get rid of the pigeons because they came down with ornithosis, and then somewhat later they repopulated it with a motley group, including one seconded from the United States. But Gordon thought that I was a virologist that the USDA sent over to work on scraping. Well, the last thing I said, no, I'm a pathologist, and that's what I was told. I was going to join this going group as a pathologist, work on scrapie. And, the last thing he needed, he felt, was a pathologist. I was assigned to Ian Pattison, another Scotsman, an Aberdonian, very nice man to work with. He had long experience with scrapie when he was in Scotland at the Morden Institute. And I got involved then in the work on scrapie. And Gordon helped all he could by smoothing it for me. He accepted the fact that I was there as a pathologist, working with Pattison, who was supposed to be the pathologist for the project. And he let me do what I wanted to do. He didn't bother me.
So most of their work was aimed towards what?
Well, they did a lot of animal work. And what was happening at the time I got there was that with this renewed interest in scrapie as a result of the embargo on British sheep, which really was an affront to British stockmen, Pattison and Gordon had embarked on some studies involving goats. Some French workers earlier in the 30s had demonstrated that the goat is susceptible experimentally, and I think they actually reported a natural case of scraping. So Pattison and Gordon were inoculating a lot of goats, and lo and behold, they found that the morbidity in goats was 100% if you inoculated them intracerebrally with the agent they were using at the time, or the inoculum, in contrast to about 25 or 35% in the sheep that most people used, usually a Cheviot. Well, this was a really important finding, because here maybe we might be able to use the goat as a bioassay for the agent.
And the incubation time was?
Well, they were working with, after they'd passed it in goats, I don't know, 5 or 6 times, the incubation period came down to somewhat less than 9 months. So it wouldn't have been too bad. And we had all kinds of animals, and as far-fetched as it might seem, you could use the goat to at least get some idea of the concentration of the agent by titrating it intracerebrally in goats. Well, before that really got underway, Dick Chandler came along and reported that the mouse is susceptible to the agent. Well, that was going on, so we did a lot of goat work. Pattison did a lot of goat work.
So that wasn't pathology so much.
It wasn't pathology. They were interested in what things they could do to the agent and still keep it infectious. Something about incubation periods.
When you say do things to the agents, this was the
physical changes, whether heat, formalin, and other manipulations that they might do. That was one of the things they were interested in. And then the director had a 24 breed experiment going, testing the susceptibility of the different breeds to the scrapie agent. And he found a great variation.
This is in sheep now, right?
This was, pardon?
In sheep?
This was in sheep.
Yeah.
And this was sort of prelude to the whole idea of the matter of genetic genetic susceptibility of sheep to the scrapie agent, which we hear so much about now. At least it pointed the way then. We didn't know anything about those genes that control that, but there was certainly evidence that there was something like that going on.
Why don't you give us some idea of what happened when the Parry paper appeared about hereditary,
we dealt with
and the Oxford group with the myopathy?
We dealt with scrapie as an infectious disease. You couldn't transmit it, and there was an infectious agent there. However strange it may have been because of its extreme resistance to various manipulations, heat and formula and so forth. There was the group at Morden was doing similar work, but H.B. James Parry at Oxford was doing his own thing with the group there.
What unit was he in at Oxford?
I don't know specifically what unit. He was
in the medical school? Or?
It was the medical school, because he worked with two of the neuropathologists there. But he had quite a few Suffolk sheep breeders together, and he had obtained their confidence. And many of the sheep breeders were reluctant to share information about their flocks, but he had their confidence, and he'd gotten a lot of information on the breeding patterns and whatnot. Anyway, this gave rise to his notion that scrapie is an out-and-out genetic disease. Well, then one of the real, another impetus to this renewed interest in scrapie in Britain was the heretical paper that came out in 1956 in the Lancet with a supporting editorial. Essentially, scrapie isn't a disease, isn't a neurologic disease. It's a disease of skeletal muscle, and they likened it to human muscular dystrophy.
The authors on this were?
It was Bozanque, Francis Bozanque, a neuropathologist, Peter Daniel, another human neuropathologist, and then Parry. And I think what irritated the veterinary scene, especially those who've had experience with scrapie and dealt with it as an infectious disease, as much as there were questions about just what was going on and what was the nature of this infectious agent, the idea that, boys, over the years, you people working on scrapie really muffed it. Looking for those neurons with holes in them, that is meaningless. It's a disease of skeletal muscle. Well, of course, they set out to shoot that down right away, which was done without much loss of time to the notion that it was a disease of skeletal muscle. Tom Hullen was working at the Morden Institute at Edinburgh. He had a good study, meticulous study on skeletal muscle of sheep affected with scrapie and disproved.
Well, he found what?
Well, he found some...
Nothing.
Essentially nothing, the odd lesion, but nothing like would support the idea that this was a primary myopathy.
Yeah.
And then I looked at some muscle too, and others may have. So this set Parry apart from the mainstream workers of, in the scrapie world in the UK. And he was always dealt with rather harshly, and I often thought unfairly, in any discussion of scrapie. And they never let him forget this 1956 muscle fiasco. They always nailed him on that, poor old Parry. Well, I had good rapport with Parry, and I think he knew that we didn't agree on everything. But I never let that bother the exchange that we had. And unfortunately, the man died before he had completed his magnum opus on scrapie. But fortunately, a colleague did put out the little book that eventually appeared. And it's great for a historical fact about scrapie. Well, anyway, that set Perry apart. So the two groups, Compton and at Edinburgh, working on scrapie as an infectious disease of the central nervous system. Israel Zlotnick, who was up at Edinburgh, was doing the pathology then. And at that time, you diagnosed scrapie by looking for vaculated nerve cells in certain nuclei of the medulla.
Specifically?
And these were just vacuoles in the pericardium.
The nuclei preferred for that?
Oh, well, it would be some of the, maybe the lateral vestibular, the dorsal motor nucleus of the vagus, maybe the hypoglossal. You see them down in the reticular formation, might be along the median raphe. Anyway, but Zlotnick was a skeptic about this. And, well, I should point out that Perry dismissed anything you might see in the brain. And I think he was dwelling on these vaculated nerve cells. Apparently they had missed a good paper published in France by Bertrand, who was a top-notch human neuropathologist at the time, and his veterinary colleagues, on the neuropathology of natural scrapie. And it spelled it out nicely. And anything I did later was just confirming what they had.
So what was the points that were made in the French paper?
In the French paper?
Yeah.
It was they concluded it was a disease of the central nervous system. It was a disease of gray matter. There were these vaculated nerve cells and other changes in nerve cells. Essentially no inflammation, a good astrocytic response.
Did Zlotnick know about the French paper when he started his marathon?
I don't know where in Zlotnick, maybe at the time he didn't, because he hadn't referred to it. And all his skepticism about the diagnostic significance of the vaculated nerve cell. So he set on this marathon, embarked on this marathon of looking at, I figured, 10,000 microscopic sections of the medulla oblongata of sheep, with scrapie, affected with scrapie, just to convince himself, and by that time he did, that yes, indeed, in sheep affected with scrapie, there are more of these vaculated nerve cells, and they're more widely distributed than you find in the normal.
It might be worth a while to put that in historical perspective, that there had been a period when one or two vacuoles in a nerve cell, people would latch onto them.
Well, it was in 1898, 100 years ago, that Besnois and Morel of Toulouse published their report on the pathology of scrapie, in which they point out these vaculated nerve cells. And that then was accepted as having diagnostic significance post-mortem. And then there were several papers. Stockman wrote a paper in the early 20s supporting that. There was something before that, I think. They concluded it was a peripheral neuropathy. They were misled. I think it was Besnois and Morel. Yeah, they were the first ones to describe the vaculated nerve cells, but they were more taken with whatever they saw in peripheral nerves. Stockman came along in the early 20s, found vaculated nerve cells. Yeah, that was right. No peripheral neuropathy. There was another German author about the same time said the same thing. And then in the early 40s, Brownlee and Pattison and Holman had papers, again dwelling on the vaculated nerve cells. So it became well entrenched as the histologic hallmark of scrapie. And all Zlotnick did was convince himself that this was so.
Well, you remember, I think it was on a quantitative basis. He placed it, wasn't it?
Yeah.
And what was the result? Was over 5% or something?
Well, I don't know. I mean, a number?
Yeah.
It was...
In other words, a few vaculated neurons.
Well, a few in the dorsal motor nucleus of the vagus. You see that in sheep, cattle, cats, pigs, and I've seen in some other animals, I think. But when you see them outside of that nucleus, or many more in that nucleus, that's when they have some significance. I'm not sure what the USDA used in the early days, but they were essentially following that. Well, Zlotnick was a great person to deal with up there. Most of the others up at Morden played it pretty close to the vest, so you never got much information, although I made many trips up there officially as a USDA employee wandering around the UK. But at Compton then, I concentrated on the changes in the brain and spinal cord of goats mainly affected with scrapie. And these were all from their experiments. And you know, most of it was based on clinical observation. The goat had scrapie, and so that served its purpose. Yeah. So it was discarded. Sometimes the brain was taken out, and they might look for vacuoles in the medulla. But so I really salvaged a lot of brains and spinal cords from such animals, and that was the basis for the work that I did over the 3 years in this pigeon house. And the director had given me one of the top histotechs, and he produced beautiful sections, including complete cross-sections of sheep brains. And he was a master at doing cahals, because I became quite impressed with the astrocytic response. And the only person who had really pointed that out was Bartran and Correa and Lucum in the French paper. Nobody else mentioned that. And then as far as the spongiform change that we hear so much about, that was quite pronounced in these experimentally infected goats. In fact, the thalamus of some of these goats looks honeycombed, and more so than you'd ever see in a natural disease. And that's true for most of the experimentally induced transmissible spongiform encephalopathies. But I think if you read Zlotnick's early papers, he doesn't mention the spongiform change. He does mention other changes, and eventually he gets in talking about the astrocytic response. But then it's only, I think maybe sometime in the early 60s, and sort of incidentally, he mentions what we would now call the spongiform change in the neuropil. Well, that was sort of completed the story then.
You know, I've always wondered whether that wasn't associated to some degree with histotechnique. If we think back to those days, how difficult it was to cut even a 5 or 6 micron section, and they were often 7 or 8.
Yeah, I was cutting them at 10, sometimes thicker.
No, I was thinking about the regular the paraffin section.
Yeah.
And of course, to judge the spongiform changes, obviously easier on a thin section than a...
By experience in working with Gerald Wells in Britain, he pointed out to me, and I agree with him, that when you're dealing with the spongiform changes that we deal with it now in this group of diseases, that you can demonstrate this and appreciate this much better in, say, a 5 micron section stained deeply with eosin than in one maybe twice that thick. The holes get blurred, and I agree with that. Well, I worked up these some 40 goat brains, and that was the basis for paper. But I was impressed with the astrocytic response that we demonstrated with Cahal stain. We were using a technique that the technician had gotten at the Radcliffe Infirmary in Oxford, where he had received his training. And in those days, those lads and young ladies got darn good training, on-the-job training, under that sort of program. So he was well trained. And then this spongiform change, I never was taken that much by holes in nerve cells, as I call them, these vaculated neurons, the vacuoles in the parakaryon. They're there, but sometimes it's a little reassuring to find them when you don't see much else, when you're looking for the evidence, microscopic evidence of scrapie in a Cheviot sheep. That they can be so darn subtle that sometimes it's reassuring to find a plethora of vaculated nerve cells to sort of confirm the diagnosis.
You know, it's strange though, isn't it, that there are some of our colleagues out there that think that the spongiform name really means the vaculated neurons, because in their mind the hallmark of the lesion for scrapie are the vaculated neurons. So when they think of a spongiform encephalopathy, they think of vaculated neurons, whereas what is one of the few spongiform diseases that has vaculated neurons?
No, you find, of course, that's, you know, as we've mentioned, it's
Well, I
been
think the
associated,
CJD and so on.
associated with scrapie.
Mm-hmm.
But then when I stumbled on this uncanny likeness of scrapie and kuru
Mm-hmm.
by looking at this exhibit in London.
Where
they-
was that exhibit? How did that come
was,
about?
well, one of my colleagues from Hamilton, Montana, from the Rocky Mountain Lab, William Jellison, a parasitologist, an old-time naturalist. He used to bring on all this dead stuff from the outside, you know, all kinds of things, tularemia, plague, and whatnot, and a lot of things from the big game animals.
Mm-hmm.
He had some tour in Eastern Europe, and he just stopped by Compton, England, as a social call. It was in June of 1959,
Mm-hmm.
and casually during dinner he mentioned that he'd seen this exhibit at the Wellcome Medical Museum in London,
Uh-huh.
depicting the strange disease of Stone Age natives in Papua New Guinea.
Mm-hmm.
Well, you know, I was interested, so a few days later I hopped on the train, went to London, sought this exhibit out. There it was, describing the clinical manifestations of this disease in these primitive people. And then beautiful photomicrographs, most of them in color. And here were some vaculated nerve cells. Well, that really, you know, drew my attention because although they're uncommon, as I understand it, in human neuropathology, in veterinary neuropathology, they had been associated almost solely with scrapie.
Mm-hmm.
So that, you know, that was the immediate conclusion. Well, then there was an astrocytic response, which I had demonstrated, at least to myself, was an essential component of the change,
Mm-hmm.
the changes that occur. And then they really didn't demonstrate any spongiform change.
Oh, in
No,
Europe.
and that's interesting part of the story too. Well, I didn't know who put that exhibit together at the
Really?
time.
There was no authors' names on it?
I didn't see any citation attributing it to anyone, but as it turned out, it was put together by Karl Eklund, and these nice photomicrographs came from Igor Klatso, who was the first man to look at kuru brains. He was here at NIH as well, a good neuropathologist. Well, this similarity seemed too strong to ignore. I didn't know anything about kuru. There were a few references were cited. I picked up those references. I was an associate member of the Royal Society of Medicine Library, so I had access to all this stuff. Took it home, thought about it. And then I remembered sometime later that Karl Eklund, my colleague at Rocky Mountain Lab, had written to me in April of 1959, pointing out this article by Gajdusek and Zigas describing this new neurologic disease called kuru. It was published in about April in the American Journal of Medicine, I think it was. I didn't read it. The suggestion was you read it, but I didn't. So I didn't know anything about kuru. Anyway, after reading what I did pick up in the library, I put together that little letter that I sent off to Lancet, drawing attention to the similarities and suggesting that in the light of what we know about the transmissibility of this strange disease of sheep called scrapie, that maybe it might be interesting to see if kuru behaved the same way.
And what was the response? You sent the letter in?
Well, I sent the letter to Lancet and didn't get a response. The next thing I got was a galley proof.
How long did
They'd
that take?
accepted,
Quickly?
well, it was a couple of weeks.
Uh-huh, that's quick.
Yeah, and they changed the spelling to British spelling in a couple of words and maybe deleted one word. Otherwise, it was printed as I sent it, and it appeared, I think it was the September 8th issue of the Lancet of 1959. Well, you know, it's gotten a lot of attention, but that was, the similarity, I think, was such that before long somebody would have recognized it. So it was just a little bit of serendipity, I suppose, on my part. But it was interesting because, you know, 40 years ago, scrapie was the only known transmissible degenerative disease of the central nervous system.
Mm-hmm.
So it was unique in that sense. But then over the years, here come along Kuru, and eventually they demonstrated that they could induce Kuru-like disease in chimpanzees,
From
inoculated
inocular
intracerebrally with brains from these natives dying of Kuru.
Uh-huh.
But then before that, well, that was sort of wound up my stay in...
Well, just tell us, was there ever any response? Did you ever get personally any response back from the letter? Did you ever see it referred to again?
Oh,
did it cause any, do you know if it caused any ripples on the surface? What did Gajicek say years later or so on?
I had heard that there might be a printer strike in London about the time that I was going to send this to The Lancet. So I sent a copy of the letter to Gajicek. Well, it so happens he was down at New Guinea at the time, and the letter finally was forwarded to him, and then I did receive a reply thanking me and so forth. Immediately after it appeared, I didn't get any other comment, but I did talk with an Australian MD who had first-hand experience with Kuru. He gave a lecture at St. Thomas Hospital in London in September of 1959. I attended, I think his name was Harry Larder, I think it was. And my associating scraping Kuru the way I did in the letter, he didn't think was too far-fetched. I think the only real favorable comment that I heard shortly thereafter was from a person that I have always regarded as my mentor. I didn't have a professor of veterinary pathology that I could call my mentor, and Jim Dawson in human pathology might have been had I stayed there longer. But it was James Robert Maitland Innes. He was a charter member of the American College of Veterinary Pathologists, a Scotsman who came from the UK in 1948 and settled and worked in the United States. And I contacted him through some letter, and we had an endearing relationship over the years, epistolary. It was by letter, typed out red and black part of the ribbon, wrote in ink up the side, across and down here, and it was always, every year is Hamish. And I had gotten more encouragement and the sort of guidance that I needed in my stumbling to become a veterinary pathologist from Dr. Innes. And it was some years after we started our correspondence that I met him back here. It may have been at AFIP or somewhere here in the area at some meeting. But he thought very highly of that, drawing that comparison, because over the years he was a great component of comparative pathology before it became fashionable and certainly before it became a fundable endeavor. And then it's been referred to over the years. I think much has been made of it, more than needs to be, but as I say, it was a similarity that I think would have been stumbled on by others eventually.
But it was in its own way,
anyway,
it was a seminal observation.
I didn't meet Karl Gajicek until that fall of '59. It was in November that a group of us from the UK came to the United States. There was John Stamp, who was the director of the Morden Institute at Edinburgh, William Gordon, who was the director of the lab where I worked, and then Morris Shahan, who was director of Plum Island at the time. He was sort of the head man representing USDA. And then James Horrigan, who was saddled with their scrapie eradication program, which was very unpopular among sheepmen. And so we had a series of lectures across the country to appease these agitated sheepmen. And the first meeting was in Washington, D.C., I don't know, late November of '59. And in the back of the room, I saw this burr haircutted fellow who turned out to be Karl Gajicek. And after the meeting, he came up and he talked with me, and that's the first time I met him. And that led to a long relationship professionally over the years. And we may have talked about the Scrapie-Kourou connection. I don't know.
At that stage, had he done anything with the transmission of
No.
Kourou?
See, this was reported in '59.
Right.
Suggesting that that might be a good idea to inoculate some non-human primate, which they did.
Mm-hmm.
And those chimpanzees, and they became affected. Well, he reported it in 1966, 7 years later.
Oh, okay.
Well, that's that part of the story. I finished off my tour
Mm-hmm.
in the UK,
Mm-hmm.
and got all my things together on the neuropathology of experimental scrapie in the goat.
Uh-huh. And did you, then you hopped on the ship and came back?
Came back.
And went
well,
back to?
I had intended to stay with the Department of Agriculture,
Uh-huh.
because when I left the Public Health Service, it was merely a transfer of a still civil service to the USDA, and I was to stay with the USDA and go to Denver.
Mm-hmm.
Well, things didn't work out, and I went back to the Rocky Mountain Laboratory
Okay.
in June of 1961. And I hadn't intended to, but I got back there. It took several weeks to get the paperwork in order, because when I left, I told them I wouldn't come back, and they'd given me a going away present. So it was a little embarrassing to return to the scene and ask for a job again. But I did get a job, and it was still a pleasant place to work. But then what am I going to do? I'm still there as a pathologist, looking at anything that might be coming in from others. But Karl Eklund, and I've mentioned him several times, the medical virologist, he was an MD cast in the old mold.
Mm-hmm.
He had visited me several times in England,
Mm-hmm.
and was quite taken with this matter of scrapie.
Mm-hmm.
And he was winding down his study of the arboviruses, so he was looking for something too.
Mm-hmm.
And together we put together this project on what we called then the slow viral diseases.
And you arranged for
And
an agent to...
so we
be,
had to put together some projects. And it so happened that in August of 1961, Dick Chandler reported that the mouse is susceptible.
Mm-hmm.
Well, that's all Karl Eklund needed, because he suggested that we needed that earlier.
Well, that's great. This would seem to be a reasonable time to draw. It's a natural place to draw an end to your experiences in UK, and I think we can take up the next phase of your life in the next tape, in the next hour.
All right.
Well, thank you. You mentioned about Dr. Eklund and the scrapie, and we know, of course, that there are other things involved as well. Tell us about the sequence of events.
That's right, Don. As I mentioned, I came back to Rocky Mountain Laboratory, and it was quite an unintended move. So I had to find something to do, and teamed up with Karl Eklund. We had this association from earlier days, and his enthusiasm was such that he felt we had to pursue these slow viral diseases. It was something that Björn Sigurdsson had pointed out in 1954, this whole concept of slow infectious diseases. And scrapie certainly fit. Well, then when Dick Chandler reported that the mouse is susceptible to the scrapie agent, it fulfilled one of Eklund's earlier wishes that for a small, convenient laboratory animal in which to use as a bioassay. So we were going to exploit that right off, but we needed to get the scrapie agent. And I happened to be at a meeting somewhere, I guess it was a meeting in Rome. On the way back, I stopped at Compton, or as a social call to the people with whom I'd worked for 3 years. And Ian Pattison gave me some of the mouse brains. I think it was Second Passage. Brought them home in a thermos bottle, and that started our mouse work at Rocky Mountain Lab. Well, in those days, the the United States Department of Agriculture kept close tabs on what was moving around. Not only the agent, but even the glass slide of section of brain had to get a permit to at least let them know what you were doing. So we inoculated mice, and Eklund's view was we have to know more about what's going on extraneurally. There's obviously something going on there before the agent reaches the central nervous system. So that was the basis for the initial study in the mouse, determining where it replicated.
After infection by what route?
Subcutaneous in this case, because there's a difference if you inoculate them intracerebrally. This was subcutaneous, and found that the agent replicates early in this long incubation period in lymphoreticulated tissue, lymph nodes, spleen, and the lymphoid tissue in the gut. Oh, that was extreme interest. But then we wanted to get on to some large animal work. And since I had worked with goats in England, I was impressed with the susceptibility of the goat over the sheep. We decided to inoculate some goats. I'm not sure well, initially we wanted to produce disease in the goat, and then we were going to do a similar study in the goat to determine the extraneural distribution of the agent during the long incubation period. I didn't have decent facilities for housing goats the way they had to be, but they did prepare a place where I could keep 8 goats. And I had to have USDA approval. So they sent out an inspector, which was fine. I showed them what we had and how we were going to handle things, burn all the refuse coming out, and change the clothes going in. And finally, in the end, he said, do you think the facilities are adequate? You know, I said, well, they certainly are. I'm not going to be working on foot and mouth disease. So he approved it. Well, then a year later, we got more facilities. In those days, the Rocky Mountain Lab administration could deal with a lot of things locally. You didn't have to go through the hierarchy of paperwork to get something done. And I was able to get $20,000 by putting a little pressure on Congress through our local representative, senator. It was Mike Mansfield. And we got $20,000 anyway that we could spend there. So we built one of these pre-engineered metal buildings and started more work with large animals, sheep and goats. Well, we inoculated goats and determined the distribution of the agent in the extraneural tissues by using the mouse as the bioassay. And it worked slick. Won't get into the details of that, but so we had...
But that still must have been a very time-consuming experience.
Well, it is. Working with Scrapie isn't... any work with Scrapie just doesn't fit into any short-term project. You have to commit yourself to a long-term project.
I was just thinking by the time you waited for the goats to... presumably you sampled goats serially over almost a year, right?
Well, more than that.
More than
2
that.
years.
Took 2 years.
Yeah.
And then they went into the mice to be assayed. Then you had to wait for the mice.
Yeah. Well, you know, most people think when you mention this long incubation period, you inoculate an animal and then put your feet up on the desk and wait for a year or two. Well, you could do that, but the secret is to have something going on or coming off all the time.
Right.
And that's the only way you can sustain an operation. When you're talking about a 3-year incubation period in a goat and at least a year in a mouse when you're working with the wild agent. So you've got to have a lot of things going so results are coming in all the time. Well, we did the work. We started with Scrapie. And then...
just one thing, you sort of pointed out that the goal was to find the distribution of the agent in the body in the latent period, or at least the clinically latent period.
Preclinical period.
Yeah. And what else, what other goals were there? You already knew the neuropathology from the work at Compton.
We did some very elementary work on the physical properties of the agent, which merely confirmed some of the earlier work, got some idea of the size. It was small, using the Graticol filters that we used. Did some heat exposure. I'm not sure whether we did any with formalin. That wasn't really the big concern. We knew it was strange. But Eklund's interest was more in the dynamics of the infection, what was going on in these animals. Well, then we supplemented that with a study of the natural disease. And through a very cordial arrangement with James Horrigan, one of the men that had been on this tour across the states. He was in charge of the Scrapie field trial in Mission, Texas. The policy at the time was for the Department of Agriculture to take some of these flocks in which Scrapie had been diagnosed and take them down to this, what had been the Moore Air Base during World War II, down along the Rio Grande. It's a hellish place to put sheep, but that's where they put sheep. Anyway, it turned out to be a good place to find infected animals. And most of these were Suffolks, and that was the Suffolk is the main breed in which Scrapie occurs in this country anyway. So through this arrangement, we would go to Texas. And early on, this was about mid-60s, it took 2 days to get there. We get as far as Dallas the first day.
This is driving.
I know Hamilton is kind of out-of-the-way place, but that wasn't really the problem. It was the airlines.
Well, the airlines? It took 2 days by air.
Yeah, we went by air, went down to Dallas, and then we got one of these wild pilots in the Trans-Texas to fly us to McAllen, Texas. And then the Mission, where the sheep were kept, was some 28 miles from there. Anyway, it was a great place to collect material.
So let's explain. These sheep had been brought in from all over the U.S.
From various flocks in different parts of the country.
Right.
And they were put together, essentially, so they had a big infected flock in which clinical cases of Scrapie were occurring all the time. You go down there and see a half a dozen or more, which was great. So initially we collected material from clinically affected animals. I went down with one of the right-hand men that Eklund had, Richard Kennedy, and we became a team that worked together very nicely in cutting up these animals and collecting specimens.
So he was collecting the virological material,
Yes.
I take it.
We collected material for bioassay, and that was then frozen. I collected material in formalin and parts of the brain in formalin ammonium bromide to do the Cahals on. And in those days, we could bring all that into the passenger compartment. So you sit there with your feet on the box, and the box had dry ice in it, and the other box had formalin in it. You know, couldn't get away with that these days.
In the aircraft.
But we did that a number of times, collecting specimens. We took a lot of material down there and left it down there. You know, various things we had to wear and so forth. Conditions were quite primitive then.
Did you ever get, in the autopsy of these animals, did you ever have any undesirable incidents?
Well, we had a way of doing it and tried to be careful. We always, at the outset, felt that, I think this was Eklund's view, you dealt with the Scrapie agent as though it were potentially pathogenic for man. So you didn't do dumb things. And you took all the precautions that you thought were necessary. I never felt that I had any great exposure working with animals during necropsy. Working with material on the lab bench, grinding it up, that was a little different. Well, in doing the postmortem examination or cutting up these animals, there was only one instance where I sort of exposed myself, I guess. I was cutting through the spinal cord with a Stady blade, long razor blade, and I cut my finger. So I knew that I probably was exposed because we were finding pretty good titers in the spinal cord. So I took the adjacent piece of spinal cord and froze that and did a bioassay in mice. And yeah, there was quite a bit of agent there, but nothing's happened. Well, we collected quite a bit of material from clinically affected animals,
Mm-hmm.
and they were willing to sacrifice them for our need. But then I wanted to study what was going on in this infected flock early on in younger animals that were still clinically normal. Well, to make a long story short, we did find the agent by mouse bioassay in such sites as the tonsil, retropharyngeal lymph node, a mesenteric lymph node, terminal ileum,
Mm-hmm.
from about 10 months of age on.
Mm.
This was long before they'd ever show clinical signs. We first found it in the central nervous system, small amounts in a clinically normal animal at about 2 years. Well, that gave us a sequence of events. So that gave us a much better idea of what was going on. But what was of interest was that the pattern of extraneural replication was very much like it we found in the mouse. So the mouse wasn't an anomaly.
Mm-hmm.
And we tried to determine whether there was a carrier stage or a subclinical infection that persisted and they might shed the agent. Well, we looked at a number of animals that would sort of fit that category and never detected any. So that whole question of whether there is a persistent infection beyond the usual incubation period, so it would be sort of a subclinical infection, we don't have any information on that.
So what did you check for shedding? What
Well,
components? Saliva?
did some saliva.
Feces?
And when you inoculate a sheep or a goat with an imbutol that we use to put them down, it induces salivation, so there wasn't any problem collecting saliva. Feces were collected out of the colon, but lower colon, but it wasn't examined as enough samples weren't examined to really rule it out. We've never detected any sites of shedding,
Mm-hmm.
even in the placentas we examined.
Oh, okay.
But since then, others have demonstrated that it is shed in the placenta.
Mm.
How often, how regularly, and how the agent gets there, I don't know. So that's one of the big questions.
Did you ever look at white blood cells? Did you ever put buffy coat?
No, we didn't. We checked for the agent circulating in the blood,
Right.
but we used serum and blood clot. We never
Okay.
used buffy coat.
Mm-hmm.
And they have demonstrated the agent circulating in some of the lab rodents that are experimentally infected. I think they've demonstrated it in the mouse
Mm-hmm.
infected with the scrapie agent. But it's associated with the buffy coat, so it seems to be cell associated.
Mm-hmm.
That whole approach should be studied again in greater detail, probably. Well, I don't want to belabor the scrapie story. That was essentially our contribution. And what interested me was that in working up these brains
Mm-hmm.
from the naturally affected animals, I wasn't impressed with any spongiform change. It's a good astrocytic response.
Mm-hmm.
There was neuronal degeneration. The neurons become dark and shrunken, something that I think the neuropath text would designate as simple atrophy or chronic cell disease or
Ischemic cell change?
pardon?
Ischemic cell
No,
change?
they weren't ischemic. They
Well, you
weren't
remember
red.
that
They were
term's
dark.
used for those
Yeah.
angular dark
Yeah,
neurons.
they're
but-
dark ones. They weren't red ones. And some of them disappear
Okay.
in areas where you can make this judgment.
Uh-huh.
And that's often difficult in our animals for a number of reasons. I suppose one is we don't leave them live long enough and don't subject them to the great effort and extensive measures that are used to prolong human life.
Mm-hmm.
And then there may be some differences in the way the brain responds. But in areas where there's a great concentration of neurons, like those tiny granule cells in the granule cell layer of the cerebellum, there you can detect loss of neurons very nicely. And that's often missed. And scrapie is a cerebellar disease, along with other things. So you can see loss of neurons in the granule cell layer of the cerebellum. Well, anyway, I didn't see the spongiform change that everybody talks about now. But I did see it later, and I could...
Just for a moment for clarification. This gets back to the definition of a spongy and the misconception about the spongiform encephalopathy. In other words, scrapie, viewed as the archetypical transmissible spongiform encephalopathy, often does not have pathologically or histopathologically a spongiform lesion.
Well, I would say it was often, in my experience, looking at suffix, and Elizabeth Beck, who looked at a lot of H.B. Perry's suffix.
Right.
He worked exclusively with suffix, his story of the hereditary disease. She states that she didn't see the spongiform change in her animals.
Yeah.
Well, it occurs in other breeds.
Sure, but it's sort of somewhat ironic, though, isn't it?
Yeah, we could talk about that later. It occurs in other breeds. So that would include it with the spongiform encephalopathy, I suppose. Well, that's pretty much the scrapie story. But Eklund...
Did that taper off from then on, or did you continue with scrapie work up until virtually the time you left Rocky Mountain?
Considering all the titrations we had to do, you know, one time I had 10,000, well, all the time, I had 10,000 mice on the shelf. Can you imagine what, you couldn't do it today. The per diem would kill you off.
That's incredible.
And I had a good place for it.
Yeah.
You had to change clothes to go in, had a good crew, they were well disciplined, and everything that came out was incinerated. Had a lab in there where you could do collect your specimens. But the secret was to have all the preparations in hand, frozen down, all the dilutions made. You know, we were titrating, and that's something that's frowned upon these days, to run a regular 10-fold dilution titration. So when there was space on the shelf, and another fortunate arrangement there was the mouse colony where they raised mice for lab use. It was a good, tough Swiss mouse that goes back to some of the early Rockefeller strain, and it had been brought out there originally because of its susceptibility to yellow fever virus. Anyway, it proved to be a good animal for our purposes. And when you're working with the wild agent, you have to have a mouse that's going to live at least 2 years. Yeah. People forget that. They want to use an inbred mouse, and their longevity is limited, and that the incubation period is going to exceed their lifespan. And, well, with agent that has received a number of animal passages, the incubation period is shorter, and the clinical phase is more stable, and you can get away with it in mice that have genetically a shorter incubation period. Yeah. But they make a mistake when they work with the wild agent. You got to have a tough mouse that's going to live 2 years, because when you do your titrations, it's going to run out at least 18, 19 months sometimes. Yeah. Well, so you have all this stuff prepared. Always use female mice, because they get along fine. Males will fight. If you have males and females, you have to keep plucking litters out, you know, that nuisance. And when you got 10,000 mice, you can't have that kind of nonsense going on. So you got an opening on the shelf, you got stuff to go, you go to the mouse people, I need a couple hundred female mice 21 days old. If they get a little older, you can't put the needle in as easily. The calvaria gets a little too hard. So you set them up, and then, oh, maybe it takes a year before the animals get sick with wild agent. And then you do titrations, it takes more months. Yeah. So it's that sort of, well, I did that almost until the end when I left. I still had titrations going. Well, so that was the scrapie work that continued. Right. But, you know, Eklund wasn't content. We had to do other things as well. It so happened that in the spring of 1962, there was evidence that this disease of mink called Aleutian disease was, in fact, an infectious disease. And it wasn't a genetic disease that they had assumed it was, because it occurred first in this color phase called Aleutian. It's a autosomal recessive. And we knew from the natural history of the disease that it was a long-drawn clinical course. Oh, that might be another good candidate for our slow viral disease project. So that got us into the mink business.
Mm-hmm.
Well, that was a new animal I'd never worked with. Had to get tooled up for that, design and build mink sheds, mink cages, line up proper mink feed, a source of mink that were clean, because Aleutian disease was widespread in mink herds in those days. And if you found a herd where your mink were clean, you were well ahead of the game, and we were. I found a small herd. We tied them up with a contract, looked at everything that died, did periodic tests. The herd remained clean for 16 years, and he never used any vaccines for enteritis or distemper, which at the time someone suggested might influence their susceptibility to the Aleutian disease, as it turned out, a parvovirus. So we got started on that, and that was interesting work. I obtained the virus from John Gorham over at Pullman, Washington. And once we got tooled up to handle mink, we were working with two color phases, pastel, the brown ones, and sapphire, which is a double recessive, Aleutian plus platinum. They're kind of a light gray. Very much more susceptible to the Aleutian disease parvovirus than the brown one. And we did comparative studies. We were interested in the distribution of the virus, when viremia appeared, relating this to the appearance of clinical disease, and to the lesions. Looked at a lot of affected mink, post-mortem. And it was fascinating. It's a little vicious beast you have to get used to working with. But so we had a number of things going on with the Aleutian disease virus, and Eklund had set up a number of projects to get a better idea of the properties of this virus once we can, or agent. Well, it was, I think they determined by some filtration studies that it was a virus. Didn't know it was a parvovirus. But Eklund, with his studies, determined the size and some of its other physical characteristics, and it's resistant to various things. It's a little more resistant to heat than some other viruses, not like scrapie though, and a little more resistant to formalin. Because I think that's how one of the first clues that it proved to be an infectious disease. It was a custom of ranchers to take spleens from mink dying of distemper, and grind them up, mix some formalin with it, and use this homemade vaccine to vaccinate their mink. And I guess it was effective in preventing distemper, but the Aleutian disease virus was so rampant in those days, and it slipped through this inactivation procedure that they brought a lot of mink down with Aleutian disease. That was one of the first clues that there was a transmissible agent associated with it. So we got into that. But we talked about Kuru earlier, and that was eventually shown to be very much scrapie-like. And the agents are essentially indistinguishable. But before that was actually demonstrated, and that was reported in 1966, a second animal example of transmissible spongiform encephalopathy came to light, and that's the transmissible mink encephalopathy, or TME for short. It's a disease that had occurred, first recognized in 1947 in Wisconsin by Gaylord Hartsaw, and he was an old-time mink veterinarian in Wisconsin that was knowledgeable of mink diseases and the whole husbandry of mink, of anyone that around. And then he didn't know what it was, but they did look at sections of brain, and whoever examined it, pathologist, concluded that this was evidence of a neurotoxicosis. And well, that was it. Some noxious substance on the farm that they were exposed to. Then the disease occurred again in 1961 and affected 5 farms that were sharing the same feed supply. And that gave them a clue that maybe the feed was the source of this agent. And then it occurred in 1963 in Blackfoot, Idaho, and that's when I was introduced to it. I was asked to go down there. It somehow got mixed up with the Public Health Service, and someone thought it might be toxoplasmosis. But, you know, would you handle this fellow's request to look at it? So got in touch with the rancher, he brought in some mink, and assuming it was toxoplasmosis, inoculated some mice. And as soon as I sectioned the brain, I could see scrapie. And so that was a clue. We had another example of a group in this, of a disease in this group. We got more mink. And in talking with John Gorham, I was relating this incident of having gone down to Blackfoot, Idaho. And he said he had heard about it, and he was going to send someone down, but I had gotten down there before. But he said, by the way, up in northern Wisconsin, there's another disease that sounds like the same thing. So I arranged with Dr. Hartsaw to go up there, and I collected specimens from 10 mink. There are only about 100 left, and most of them were affected. It's a great morbidity in most of these outbreaks, almost 100%. And did it out on a picnic table, used a welding torch to seal the ampules where we put the specimens that we were going to sub-inoculate into mink, brought it home, and inoculated mink in September of 1963, and they eventually came down with it. So it proved to be transmissible. At the same time, the people at Wisconsin inoculated mink, and they also found that it was transmissible experimentally by inoculating mink just by some peripheral route with spleen or preferably a central nervous system tissue.
But so was the source of contamination ever found? In other words,
so here you have a disease that looks like scrapie. You know, the lesions do. Although I should say that the spongiform change is quite pronounced. You know? So if you go back to what you said earlier, it's unlike Suffolk scrapie. But anyway, it's has the good lesion, good astrocytosis, that sort of thing. Very little vacuolation of nerve cells. That's in contrast to some of the others. And then we made several passages and determined something about the nature of the agent. Since it was coming from feed, you know, the epidemiology indicated it was coming from feed, and since it looked like scrapie, and all we knew about in those days was scrapie and sheep, didn't know anything about the comparable disease in cattle, the immediate conclusion was that the rancher was putting in sheep carcasses or offal. And but that wasn't so, because more of them were using cattle. And these mink ranchers in those days would get anything they could, you know, to put in. They all made their feed, and they always had a component from the packing house. And so then the disease didn't occur again. That was in 1963, 2 outbreaks, one in Wisconsin, one in Idaho. It didn't occur again until 1985 in Wisconsin. And that time, Dick Marsh investigated that outbreak, and that rancher was quite adamant. He'd never fed any sheep tissue or carcasses. He'd fed downer cows and an occasional horse for 30 years. And so that led Dick to conclude that there was some encephalopathic agent in cattle in this country. And the evidence for that is still pretty vague, but you know, where else does it seem to come from? Well, that's mink encephalopathy was the 3rd example that we played around with. And we determined that in a serial study that it's really a dead-end infection in mink, quite unlike it is in sheep, that scrapie is in sheep. There's very little replication in the preclinical stage in extraneural tissue, but apparently enough to seed the central nervous system. So there's no evidence that of outlets for it to be shed. And that fits because it's a non-contagious disease. There's no lateral transmission. Another example that Eklund thought we ought to get into, Hadley Marsh, who was one of the charter members of the American College of Veterinary Pathologists, a sheep disease man, and no slouch as a pathologist, who worked pretty much by himself out there in Bozeman, Montana, and described this progressive pneumonia of sheep in the early 1920s. He had retired, and I got in contact with him. He brought in some sheep that he was certain were affected on the basis of their clinical signs. We did some experimental inoculations. They were, in fact, affected with the disease. Lung lesions are so typical. And we produced the disease. There was some question at the time whether it was associated with an infectious agent. I think Hadley Marsh thought it would be, that it was, but there was no good evidence for it. But we did the sort of experimental studies that he had always hoped for and never had the time or facilities to do on his own. It proved transmissible either by even inoculating him directly into the lung with a suspension of lung or intravenously. Came down, beautiful lesions in sheep and goats, probably better in goats. Well, things got a little out of hand. I got too many things going. When you had 1,000 mink, 10,000 mice, 200 sheep and goats, you couldn't fool around with too many other things. Trying to do it pretty much on your own, with a good crew to support you. Well, we continued that work for quite a while. And Dick Kennedy, this man with whom I had worked on collecting specimens, he was a good lab man. He and a few others actually isolated what proved to be the causative agent of progressive pneumonia, the retrovirus. And it wasn't pursued beyond that. I don't think we ever published much. But what's interesting is that at the time, especially in the goats, some of them had carpal arthritis, swollen carpi. It was just a damn nuisance, an intercurrent problem that was confounding the project. And here it was probably an expression of the same infection that we now call caprine, arthritis encephalitis. Well, that's interesting as I look back on it. So we were involved in that kind of work. And over the years, since we had so many mink, and I had facilities whereby I could keep them long, nobody was bothering me. And although I had good husbandry and I dealt with these animals very carefully, I didn't have all the constraints that people have now from the animal care people, animal use committees. I ran my own show. We had an animal department there, but I had my own show, so I had direct control over everything that was part of my show. And I could keep these mink as long as I wanted to. Well, I let some of them to get pretty old. And some of those brown mink would get to be 7, 8, 9 years old, which you never see on a mink ranch, and they're gone in about 3 years. And a lot of interesting things came up that would interest a pathologist. Lesions in the eye, a lot of neoplasms. So that was a little part of the kind of a side study of the slow viral disease program that was of great interest.
Was the aging lesions in?
It was aging lesions, or lesions that occur with age, with advancing age.
Mink.
And vascular changes, chronic gastritis, which no one else has recognized, atrophic gastritis. My interest has always been in the disease and the whole natural history of the disease. I guess I'm not a real bench worker. I've had some go at it, but I'm not what you would call a real bench worker. I let others do that. I'm interested in the whole disease. And that's what fascinates me. And I suppose it gets down to to what your view is as what is disease. And I've always felt over the years that it's really not dealt with in any explicit way in a lot of the textbooks when they deal with the nature of disease. You come away with, human pathology texts or even the veterinary, I come away with a feeling that I don't really understand a good definition of physical disease. I know disease, the term is used more broadly, but physical disease that we usually deal with. But I came across something that I thought fits the way I think about it. It's the normal responses of a genetically fixed body to injurious agents of all kinds. Well, that may not suit everybody, but it often comes up, we talk about the pathologic responses. Well, they are in terms, we use those to describe a disease. But fortunately, the animal sometimes responds that way, whether it's an inflammatory response, so it's normal in that sense. Well, that's just a little aside.
But one thing you haven't mentioned at all is it was what during this period when you made quite a contribution to the understanding of muscle disease in animals. In fact, co-authored or authored the chapter in Innes's book on this, which was really the first real description of any extensive number of muscle diseases.
Yeah.
How did you get
as
that?
I mentioned earlier, the person that I really regarded as my mentor, and this was, we had a sort of epistolary relationship, it was all by letter mostly. We did see one another, but by letter, was Dr. Innes. And he and Leon Saunders were going to put together this book on what was called eventually comparative neuropathology. And he felt that there should be a chapter on skeletal muscle diseases. This was back in, must have been about 57, 50, it had to be 57. And somehow he prevailed upon me to do that. I told him I didn't know anything about muscle. Anyway, it proved to be a major task. And I don't know how my wife put up with it because I was gone most of the time ferreting out all these old references, trying to come up with information.
But you also had a lot of illustrative material, so you must have...
I had to write around. My only immediate contact with any disease of muscle was the nutritional myopathy of calves and lambs. And in the Bitterroot Valley, it was an area where this was endemic because of the selenium deficiency. So I used to work with material brought in by some of the practitioners when I was at Rocky Mountain Lab, and it was always white muscle disease. And so that was my only
But you had a wonderful background in your training in neuropathology, but particularly in the 50s, the number of people that really knew anything about the response of muscle to injury, and so that one could have an understanding of this, was pretty small. Had you really had any or much?
No, I hadn't. I suppose I got most of it from reading Adams and Pearson's book.
Yeah, I think we both did.
That was a classic when it came out. It got worse in the subsequent editions.
Well, you remember Adams got removed Pearson and...
Pearson, he got shoved, Pearson was shoved off, wasn't he?
Yes, and so Adams produced the last one on his own, and I think the general response to it was much like you described. But yeah, that was amazing.
That's where I... So that was sort of the source of learning something about the way skeletal muscle responds to injury.
Yeah. I'm not sure all of the viewers will appreciate, probably being younger than us, that muscle diseases ended up in neuropathology books because nobody else wanted them.
That's right. It was largely by default, and it fell upon the neuropathologist.
But you remember Adams wrote in his book, and I quote, "Muscles are extensions of the nerves."
Yeah.
And of course they are, in the sense of that they're controlled. The rate of contraction, the metabolic rate, everything's controlled by the nerves. And of course, I think to most people who always get taught in the musculoskeletal system that this seems ridiculous to put the muscles with nerves. But in fact, it ended up with the neuropathologist.
That might one might expect that from Adams because he was in clinical neurology, I think. Well, anyway. So Dr. Eklund prevailed upon me to do that, and I took it on. And I had to get help from colleagues to translate a lot of from the German and from the French, and I could get some translations from the Swedish, and where a lot of the good material, the little that was available, was found. Now, I put the chapter together, and it was at the time, I went to England in the spring of 1958, and I was just putting the finishing touches on that. In fact, I think I had to finish it after I'd gone to England, as far as getting all the photographic material together, and then sent it off to Innes, and got the galley back. Well, he did something to one of the plates. He didn't arrange them the way I had originally planned. But anyway, the chapter came out, and it proved to be a little more extensive than I think maybe Innes thought it might be, and certainly more than I thought it might be. But it was a major
contribution. It really was a major contribution.
Well, that sparked my interest in diseases of skeletal muscle, and I pursued it for a while. I even gave lectures to the Davis Foundation until I got so outdated. I told Dr. Thompson that I could no longer do it. But it's still of interest, but I haven't dealt with it in any immediate way these days.
You know, one thing we should take up, because I think time's starting to run down slightly, is tell us about the last years at Rocky Mountain and Lab, and the way things went, and what your interests were then. And,
when I mentioned earlier that at Rocky Mountain Lab, their major thrust was on these infectious diseases of so-called of nature that, well, some of them were zoonoses, but they were an infectious disease that had some relationship maybe to a vector, an arthropod vector, something like that. And then they were undergoing a transition. They were getting into other things, maybe because techniques were changing.
This is in the 80s?
This was, I could detect it in the 50s, and then in the 60s it was even more so when I came back to Montana. And then in 1978, the show came to a crash. My show did. And I don't mind disclosing, won't go into some of the grimmer details, but there was a change in the administration in Bethesda, and the scientific director, who was sort of the immediate head over the local director. At that time, Rocky Mountain Lab was made up of sections, and we had a resident director. Well, they changed that, kicked the director out, and made individual labs that would correspond to the laboratories here at the Parent Institute in Bethesda. And then with the present communication systems, they could sit in on their lab chief conferences and so forth. And then the whole program was changing. Animal work was downsized, is the word today, and becoming all molecular. There was going to be a whole change in staffing. Not this stable, permanent staff, maybe a 1/3 permanent staff and 2/3 floaters, 2-3-year people, postdocs, things like that. Well, that's the way it's gone. But I got caught in the shuffle, and I was stripped of everything. I was summarily shut down, lost my whole animals.
You had all these animals in the
and I had to taper them off as well as I could without doing anything new. And after having put in so much work, it was a little difficult to accept. Maybe I did get a little bitter, I'm not sure, but probably did. And then I think my last sort of hurrah was that Stanley Prusner, we were doing work with him beginning back in 1972, doing some of his mouse titrations and getting him started on his work on Scrapie. And that was summarily shut off. But anyway, Stan Prusner and I had established a working relationship, so we thought we'd have a symposium to honor Karl Eklund on his 75th birthday. By this time, Karl had retired, But he still came around, still was as keenly interested in the project, and I was still pawing over data that we had assembled and trying to pull together what was left of the show that had been scuttled.
What year was this?
78.
Oh, okay, 78.
Well, unfortunately, Karl Eklund died in November of 1977. But we put it on anyway in his memory.
Okay.
And that was a good 2-day program.
That was at the lab?
That was at the lab. Well, from then on, things went down. The next thing I knew, I didn't have any control over my animal caretakers. I was down to one technician and one histotech. Then I was down to one histotech, and he happened to turn out to be probably the best one I had. I mentioned earlier that I had this fellow that I trained. He did it my way, so he pleased me. He was with me for 20 years. Then I had one in the interim, including one from the Army that didn't work out. Then I got a cowboy from Colorado Springs, Colorado. He was first class. He could troubleshoot. He knew everything. He was brought up under one of these hard-nosed senior histotechs on the job, and he was first class. Well, he decided to go back to the Penrose Hospital in Colorado Springs, so I lost him. In fact, I encouraged him in view of what was happening to my show. So then I didn't have a technologist. I was down to a lab, and a few things I was doing. I was fooling around with some carotid bodies in Mink. I had embedding them myself and cutting sections. And by the way, over the years, I always took, at least once a year, cut my own sections, just for the hell of it, to demonstrate that I could still do it. But here more recently, we had all the fancy embedding equipment, which made it much easier, instead of the old paper boats and whatnot. But so then it gradually tapered off, and eventually I found myself alone with a lab that I couldn't do much in, and I had to justify my existence. Well, I don't want to insert a lot of sour grapes or bitterness, but it finally came to the point where the most prudent thing was to say goodbye.
So how many years did this sort of process take place over?
It was 8 or 9 years. So I retired in the end of May in 1987. I could have stayed on, but everything was going molecular, and as I said, that was not my line of country. And the animal work had decreased. Now, ironically, since then, I get called to look at material from animals that are still being used. There's no pathologist to look at them.
Actually, in the last few minutes, if we just look at that period of your life and just see what the contributions were, they're fairly diverse, but there was the muscle chapter, and then there was, well, let me not go through them all. Could you just sort of to summarize again as you see the interest and the things that you reported on, and I mean, you've had papers and contributions at meetings and all sorts.
I suppose the one I look back on is one that I thought might have been a dissertation, but it didn't work out that way. It was on the neuropathology of Scrapie and the dairy goat. That required a lot of work, and it was interesting to have done it. And then the muscle chapter that came out about that time, and Dr. Innes and Saunders' book. And then working with Karl Eklund. I wish I had learned more from him, but it was great working with him while he was still active and even after he retired. We did this early work on Scrapie, demonstrating that there was an infectious disease and there was this pattern of extraneural replication of the agent in the mouse. The mouse could be used as a bioassay. The same pattern of extraneural replication was found in sheep and goats, naturally infected. Got into this fascinating disease, illusion disease of Mink, and working with an animal that was entirely foreign to me. But I came to like, as vicious as the little devils are every year. They're born the 1st of May, and they're just as vicious the next year when the new crop comes around. learning about mink pathology, apart from the intricacies of elution disease and mink encephalopathy. I suppose it was essentially that. We recognize that mink encephalopathy is scrapie-like and another transmissible disease. And I suppose looking back on it, pointing out that the similarity of kuru and scrapie really started things off.
It did. Actually, we've got a little bit of time left. Why don't you just quickly sum up? You've looked at some of the CJD that went into chimpanzees and the kuru that was transmitted and so on, and also the scrapie that went into non-human primates and so on.
Yeah.
Are you able to pull that together?
There is one thing that I didn't mention that might be of interest. You know, these days we hear so much about the BSE agent, possibly pathogenic for man because of the similarities of the two agents demonstrated in the lab. But I think what's forgotten is that one of these spongiform encephalopathy agents from man will produce disease in a ruminant, at least experimentally. Stan Prusner and I and a few of my colleagues inoculated goats with specimens of brain from patients dying of Creutzfeldt-Jakob disease. And the goats came down with a neurologic disease that clinically was indistinguishable from scrapie. Under the microscope, you couldn't distinguish it from scrapie. So it brings up the matter, is scrapie as much an etiologic entity as it is a clinical pathologic one? I don't know. But that, you know, it brings these agents closer together, the animal diseases and the human diseases. And as far as the other experimental animals,
well,
there's a great variation.
Well, we've come to the end of our time, and obviously we haven't heard the BSE story or all the great contribution you've made since you, quote, officially retired, and I think we'll do that in the next tape.
Fine. Be happy to do that, Don.
Thank you. Well, Bill, you retired, at least officially, from the Rocky Mountain Laboratory in 1987, but you've hardly been inactive since then. Tell us a little bit and give us some perspective on the BSE and what's happened.
That's right, Don. I haven't been idle since I retired. Been quite active. Certainly couldn't lose sight of scrapie and all what's going on with the transmissible spongiform encephalopathies, and I think one event that has really been the impetus for increased interest is the occurrence of bovine spongiform encephalopathy, or BSE. And that was of interest because it was in the late 70s when we were still going down to Mission, Texas, collecting material on these scrapie sheep. We had suggested and talked about exposing cattle to the scrapie agent. And that was, I suppose, largely from the standpoint of concern about the origin of the agent causing the mink encephalopathy. At least that was Dick Marsh's idea. And nothing was done right then, but in the end they did inoculate some cattle with what I would call wild scrapie agent right out of sheep and goats. Produced neurologic disease in a few of the animals. The lesions were quite subtle, altogether different from what we now know as BSE. But this was before we knew anything about BSE. Well, then BSE comes along, and the description of the lesion is quite different from what we found in these cattle inoculated with a scrapie agent. So I became friends with Gerald Wells at the Central Veterinary Laboratory in Surrey, England. And he arranged for me to come over there. He stayed with me for a week in 1989, and we got to know one another a little better, and so he arranged for me to come over, and I spent the summer in 1990 in his lab just looking at brains from BSE cattle. And that was extremely interesting. I got a good feel of what was going on, looked at least 100 completely. And then I was exposed to, well, I saw some of the animals clinically, and much other material was available. At that time, and in subsequent years, I've been going over at least once a year, looking at material from some of the antelope that have come down with similar encephalopathy, apparently from the same agent. And that encephalopathy that's occurred in the big cats in the wildlife parks, cheetah and the ocelot and the cougar, and then the disease in the domestic cats. So there was an array of material to look at, and it was of interest because given a single agent, the BSE agent, it does one thing in cattle in terms of the kind of lesions. It does another thing in domestic cats and another thing in the African antelope in the wildlife park. So that was of interest. So then, along with that, I engaged in some work with John Gorham and his associate Mark Robinson over at Pullman, Washington. And Dick Marsh was in on it too, and Gerald Wells. We were interested in knowing the pathogenicity of the BSE agent for mink. And I suppose because John is, or was at that time with the U.S. Department of Agriculture, he was able to get the agent into this country. And mink were inoculated intracerebrally and given the agent orally. And in both instances, neurologic disease occurred. The brains were sent over to Gerald, and he prepared them. And then when I was over there, we looked at them. And there's a similarity to the transmissible mink encephalopathy, but there were differences. So the agent coming out of BSE cattle is pathogenic for mink, but it wasn't producing quite the same pathologic picture in mink that we see in the natural disease, which Dick Marsh assumes or presumes comes out of comes from cattle.
Was that experimental disease in the mink? Was that different in the type of lesions, or was it different in the location?
Mainly the location. I forget. It seems to me that the hippocampus wasn't affected in the BSE mink, and it's regularly affected in the TME, the regular mink encephalopathy. And then I think maybe the cerebellum might have had some lesions. I'd have to review that. And one of the distinctions of the TME in mink is the sparing of the cerebellum. And then, well, that work was done, was of interest. But still thinking along this line of the susceptibility of cattle to mink agents and the susceptibility of mink to cattle agents, we decided to inoculate cattle at Pullman with the mink agent. And by this time we had 3 isolates, I guess you could call them, or there were 3 different sources of the agent. One was the most recent isolate or instance of the disease in 1985 in Wisconsin. Then I happened to have material put down 27 years before in the deep freeze from the outbreaks in 1963. And all 3 of them then were put into cattle and produced clinical disease in all of the cattle. And what was interesting to me, I didn't see these cattle clinically that often to get a good picture of what was going on. But the lesions were the same in all 3 groups, with prominent spongiform change in the neuropil, a good astrocytic response, and the whole picture was easily distinguishable from that of BSE, although some of the same structures are affected in both.
Such as?
Well, some of the nuclei in the brain stem, but you didn't have that constant pattern of spongiform change in the nucleus of the solitary tract or the nucleus of the spinal tract of the trigeminal nerve. Those are two that, if you see those in a BSE brain, or in a cow brain, that's BSE. That wasn't so in this case, although some of them are affected. So that was of interest. And clinically, the disease was easily distinguishable, or was distinguished from BSE. So here was another instance where...
So the change in the temperament was not the same?
No, you didn't have that aggressive temperament that would give it the sobriquet of mad cow disease. No, it didn't have that. There was a disturbance in locomotion and some change in awareness of their surroundings, and more or less more subtle changes.
So is that what agents have actually gone into cattle over the years that you know of? What agents? Obviously the TME agent went in because we've got the BSE.
Yeah.
And any others? Is the
scrapie.
Now the scrapie did what though?
It produced very subtle lesions.
Oh, that's right. You mentioned that.
Not even a modicum of spongiform change.
Right.
And but an astrocytic response, moderate in most areas, and some neuronal degeneration.
Okay.
Some vaculated neurons, vacuoles in the perikaryon.
But Creutzfeldt-Jakob's
But
never gone
you'd
back
have to look, and it was widely distributed from the septal area caudally. So.
Well, has CJD gone into cattle?
No, not that I know of. Randall Cutlip at Ames at the USDA lab also inoculated cattle with the scrapie agent, and his results were essentially the same as we found down in the Texas cattle.
I see.
And it's also interesting that when these calves were inoculated with the 3 isolates of the Mink agent, we made a second passage of the Mission Texas scrapie, cattle scrapie agent. And it came out looking the same. And it was a nice contrast because you had these 3 that had gotten the TME agent and good lesions, florid lesions, and these 3 that had gotten the second passage of the scrapie agent in cattle, still the subtle lesions. And so, the feeling was that, well, maybe if I pass scrapie agent a few times in cattle, it'll come out looking like BSE. Well, all we could conclude from that is that it takes more than 2 passages of this wild scrapie agent to make it look like BSE, either clinically or in terms of the microscopic changes. So that was an interesting little study. And I think they've continued with some more work over there in inoculating cattle with the scrapie agent. One of the animal spongiform encephalopathies that is of real interest to me now, and if I were still active, I would become involved in some work on it, is chronic wasting disease of the North American cervids, mule deer and elk. And that has an interesting background. It was recognized for about 12 years, beginning in 1969, in these captive herds in Wyoming and Colorado, and they didn't know really what the cause was. Some thought it may have been nutritional, associated with confinement or exposure to toxic substances, or maybe even the stresses of confinement. I don't know whether they ever thought about infection. But, and if they ever did necropsies on these, no one looked at the brain who, from my standpoint, knew anything about evaluating changes in the brain. Then Beth Williams came along about 1979 or 80, and she and her major professor at Fort Collins, Stuart Young, looked at the lesions. There was good spongiform change in the subcortical gray, astrocytosis, and some neuronal evacuation. And they concluded it looked like scrapie. Well, their surmise was correct, and it proved to be scrapie, like scrapie in the sense that it is transmissible, and certainly seems to be contagious. It's transmitted laterally.
That agent's been put into what animals?
That hasn't been reported in detail, but it was put into a mule deer fawn, a squirrel monkey, I think.
Oh, really?
Mink, and I haven't seen the mink brains, I would like to, and a goat. And I'm especially interested in looking at the goat brain, see if it looks anything like scrapie. Because although the people put the BSE agent in sheep and goats, the description of the changes aren't that detailed that one could conclude it really looks like what I see scrapie in the goat. And now the disease has increased interest because it's been occurring in free-ranging mule deer and elk in north central Colorado. And I've had the opportunity to look at some of that material. It's the same disease as that which has been occurring in the captive herds. So it brings up the whole matter of the epidemiology of this disease, what's going on. We know nothing, essentially nothing about the agent and its experimental host range apart from those few animals. And now what's of interest is that this was known before, that when it occurred elsewhere, it was usually from the movement of animals from these wildlife facilities in Wisconsin and Wyoming. But now it's appeared recently in a couple of elk farms in South Dakota, and I think an elk farm in Nebraska. And confronted with all the furor over BSE and this relationship to human disease, there's concern now about what do we do with this and how do we control it? How long should the quarantine be on these? Well, we don't have enough information to even come up with a decent suggestion. But it's another fascinating example of one of these transmissible spongiform encephalopathies in animals. I don't know whether there are going to be others or not. But I suppose given what has happened in the last 25 years, one should keep the possibility in mind for other scrapie-like diseases to show up. All of these in animals are just variations on the theme of scrapie anyway. And whether more of these, or whether the relationship of the BSE agent to human disease, this new variant Creutzfeldt-Jakob disease, will be borne out in terms of a causal relationship, I don't know.
You may want to say a few words just to expand on that, quote, new Creutzfeldt-Jakob with the young people in UK.
I don't know whether BSE is a victim by circumstance and geography, maybe.
But the fact is that younger people have come up now
yes,
with
it's obviously different
Creutzfeldt-Jakob.
from classic Creutzfeldt-Jakob disease, which affects older persons, with a course that is extremely short, maybe under 6 months. These younger people, some in their late teens and through the 20s and early 30s, they're going on 12, 14 months, the clinical course of the disease. And then the distribution of the lesions, the lesion is different, with emphasis on the cerebellum. And then these peculiar amyloid plaques that are seen in some of the transmissible spongiform encephalopathy. And it has many features of Kuru, although they've concluded that it is distinct. I'm not sure why. But anyway, there's laboratory evidence. The molecular people have come up with evidence that the BSE agent from cattle and the agent they've gotten out of these victims of the new variant CJD are very much alike. And they've always said that the BSE agent, despite its probable origin from the scrapie agent, is at least at the moment distinguishable from known strains of the scrapie agent. Well, I don't think they have too many recent known ones. Most of those they know about go way back when they determined that they were separate strains. So there's this laboratory evidence, and of course it's given rise to this great concern about this menace out there that's going to descend upon at least the British population, and all the speculation about the number of of people that are going to become affected with this dementia. We just have to wait and see. And then the whole mode of human exposure, if indeed the bovine agent is pathogenic for man, the mode of human exposure to it hasn't been established. Yeah. And of course the immediate conclusion is that if this is so, it arises, the infection arises from consuming skeletal muscle, yeah. Beef. But then you could argue that they haven't demonstrated the agent in skeletal muscle of affected
by
cattle.
That you mean that when they've tried, they have not managed to isolate it, right?
By mouse inoculation, yeah. And the argument there, of course, is that the concentration, it still may be there, the concentration so low that the mouse doesn't detect it, and that's perfectly feasible. We could always say that for our negatives and scrapie too. So it's all up in the air, but it has everybody disturbed, and it's the far-reaching, not only the public health implications, but the economic ones when they banned British beef going to the continent, or the movement of any cattle out of Britain. So I don't know what the upshot of that will be, but that's the latest that's on the, the transmissible spongiform encephalopathy scene that commands the attention. I think BSE is dying out. I haven't seen the last figures on it. It's not disappearing as rapidly as they'd originally thought. But given the absence of contagion, and I don't think there's any solid evidence that vertical transmission occurs, and if it does, the feeling is it wouldn't sustain any epidemic. So I think John Wilesmith, the epidemiologist at Weybridge in England, I think his conclusion is correct, that it's going to disappear, given when they ceased using the infamous meat and bone meal.
Yeah, actually, I don't think that's on the tape about the perceived change that was responsible for all this BSE. Could you say a few words on that?
Well,
for people who are not familiar with it?
I think early on, when they realized that BSE was a new disease of cattle, this was in 1986 when Gerald concluded that, and then they continue to have many more cases, that they related it to the inclusion of meat and bone meal in a supplement that was commonly fed to dairy calves. They were taken off the cows, and less often to beef calves. They were left on it in these so-called suckler herds. So it was essentially a disease of dairy cattle. Anyway, it was related to the meat and bone meal, and because of the nature of the lesion, which we would generally call scrapie-like, the conclusion was that it was an expression of infection with a scrapie-like agent that came out of the meat and bone meal. So they looked into the whole matter of rendering and how this meat and bone meal was processed. And the conclusion that they came to, which is the one that I remember, is that there was a change in the rendering process that may have allowed, if it were an ovine agent, to slip through. And this change involved discontinuing the use of hexane, which a hydrocarbon they used to extract some of the fat when the price of tallow went down, and there was no longer an incentive to get all you could out of the meat and bone meal mix. And then in the process, when they didn't use the hydrocarbon, they had no need to then expose it again to heat to drive off the residual. And that is thought to have had some favorable effect on allowing the agent to survive the processing.
Was there a change from batch to continuous feed?
There was some of that, and I'm not sure and that may have involved a shortening of exposure to some of the heat.
Right.
Well, anyway, that seems to be a reasonable story. It's what do they call it, a common source of the infection. But then the feeling is that if this did arise from sheep as a scrapie agent, it either is a mutant or some change that rendered it pathogenic for cattle. It produced a subclinical infection in cattle. It wasn't apparent clinically. But then some of these cattle went back into the rendering works, infected.
Okay.
And it amounted to, this recycling amounted to blind passages, which in the lab we sometimes would use to boost the pathogenicity of an agent. Well, that sort of fits too. And then all of a sudden, with I don't know how many of these recycling passages of cattle through the rendering works, it became sufficiently pathogenic to give rise to lesions and clinical disease. Well, that story to me makes sense. And of course the concern is, will it occur in the United States? And I mentioned earlier that Dick Marsh thought that there had to be some encephalopathic agent going on in the cattle population in this country that accounted for the disease in mink. Well, it doesn't come to the surface very often because it hasn't been recognized as producing any clinical disease in cattle that I know of. And there have only been 5 outbreaks of the mink disease in the last 50 years. And the last one occurred, what was it, 22 years after the previous one. So it's a rare disease that, if that's its source. Anyway, there's concern about whether anything like BSE is present in cattle in this country. So the USDA has a surveillance program, and they're looking at cattle brains. I'm not sure how many they've looked at, but as I pointed out earlier, looking for microscopic evidence of BSE in a cattle brain is dead easy. Do it with one section, and that's all they use anymore, officially. Their statutory setup. But if you're looking, that's one thing, but if you're looking for any microscopic evidence of infection with other transmissible spongiform encephalopathy agents, including the scrapie agent, it's quite another story in the light of these subtle changes in these cattle that got the scrapie agent. Totally different. In fact, if you were just looking for BSE and didn't have in mind that there might be something else going on, you'd miss it because it's extremely subtle.
Is this the one that you told me was actually a rod cell increase, was it?
No, it does occur. This, what I regard as activated microglia, occurs. I think if you look, it'll occur in all of them. I could see it in BSE.
But when you say the changes in the scrapie into cattle lesions, when they were subtle, what was there?
Well, there was an astrocytic response.
Okay, which you picked up on Cahals again. Well, you could see with
it's
these.
best, yes,
right,
especially in the cerebellar cortex.
Okay.
And that astrocytosis, apart from a proliferation of the Bergman glia into the molecular layer, is often difficult to, for me anyway, to recognize astrocytosis. But with Cahals, especially if the astrocytic response is in the granule cell layer, you almost need a Cahals to show it. So that's one thing that has to be kept in mind, and I don't know where we're going. At the moment, there's no evidence that BSE has showed up in this country.
Well, in fact, it's only shown in, what, England, Scotland,
well,
Ireland?
it's appeared, early on, it appeared in countries into which cattle had been imported, but had been exposed in Britain, that you can understand. But when the ban was put on the use of meat and bone meal in Britain, some of it found its way to the continental countries. And it's been the source, I'm sure, of the agent infecting cattle, certainly in Switzerland. they've had, the last count I heard was 235, 40 cases, and probably more. It's occurred in France, in native cattle again, and it's occurred in Germany. And I think recently it has occurred in native cattle in Portugal, most likely exposed to the same meat and bone meal. None of that has showed up here, as far as I know. It hadn't gotten into this country before it was recognized as being tainted with this agent, as far as I know. And cattle that had been brought in earlier, they've been under surveillance. Some of them have died off. There was one case in Canada, in Alberta, and that happened to be in an animal that had been infected as a calf in the UK and was imported along with I have a dozen other calves, Salers, this beef breed, taken into Alberta. And since it was imported during this critical period, it was under surveillance. So the cattleman had to keep an eye on it, and when it went down, he had to bring that to the attention of authorities, and it was BSE. And that's the end of it there. They embarked on a big depopulation program, as most of these, the regulatory people do. They maybe overdo it, but more than is necessary, certainly for something like BSE. But anyway, it was dealt with. That was the last of that.
Do you have any predictions?
For what might happen to all this? I don't know. There was some recent concern about, well, there's always been this concern about something resembling BSE in this country, and I say we don't have any evidence at the moment, any good evidence. As I mentioned before, there may be other examples show up. I'm not sure what they're going to be. I think the casual observer looking at some sections of brain in which he sees a few vaculated neurons, given all the concern about and talk about vaculated neurons, they're rather hastily concludes sometimes that, aha, we have another scrapie-like disease. Well, you have to keep that in mind, but the recent examples of that haven't shown that these are really scrapie-like diseases. Those vaculated neurons.
Was a pig like that? Is that the story with allegedly a pig being infected?
There was a pig, and then the fellow saw some vaculated neurons in a couple of raccoons.
Okay.
And what was of interest there is that if the raccoon is susceptible to the Mink encephalopathy agent, and the disease coming out in both skunks and raccoons, from the standpoint of the distribution of the lesions, looks much like the naturally occurring mink disease. So then when he saw vaculated neurons in this raccoons, the wild raccoons, he wondered whether he might have a scrapie-like disease. So well, it wasn't, to make a long story.
That's been done experimentally then, the infection of the skunk
and raccoon. As far as the pig, I won't go into details on that, but that was another example where it was wrongly publicized that there was a scrapie-like disease going on in this pig and probably in the swine population of the United States. There's no good evidence for that, from what I know. Human diseases, there's great interest that other examples might show up, especially using the new molecular techniques that have to do with demonstrating the prion protein. And some of the possible candidates there are the atypical dementias, or the so-called non-Alzheimer degenerative dementias that have at least some of the clinical and neuropathologic features of Creutzfeldt-Jakob disease. It's a possibility. I think the big question, the one that I'm not qualified to get into, is, and would just as soon avoid, is all the concern and funding and effort is now directed toward the nature of the scrapie agent. Is it a prion, or is it something like a virus that has a genome of its own. I don't know. That has yet to be, in my mind, to be demonstrated. But that's where all the support goes. And just to put a pitch in for scrapie of sheep, we know too little about the disease, really. And it comes up all the time in trying to deal with the disease. We don't know that much really about the epidemiology and modes of transmission, let alone the bearing that the different genotypes have on the expression of the phenotypic expression of scrapie, clinically as well as neuropathologically, which would interest me because I see big differences when I look at some of these continental breeds of sheep that I've examined in England. There you do get spongiform change. There's no question about it. You know. So that would qualify scrapie to fit into the spongiform encephalopathy, even though maybe the scrapie in the Suffolk sheep might not, and the Suffolk breed might not. So, and that's not, these questions about scrapie aren't being addressed. Well, just the simple one, they're finding the agent in infectivity in the placenta of ewes. And sometimes before they actually come down with, you know, showing clinical signs. It's from an earlier lambing. How it gets there, how often it actually occurs, and you know, things like that, we still don't have answers for. Well, you can always deal with the disease without really understanding it. You know, if there's a way you can cut it down. And we know that from the past in dealing with a lot of other diseases. But so we still would like to know more about scrapie. And given the emphasis on today's research on scrapie, that's not going to happen for a while, unfortunately. But what has been the impetus for continued interest in this whole group of diseases has been was the occurrence of BSE, and now the possible causal relationship of the BSE agent to human disease. Yeah.
That's a wonderful summation of the present situation and understanding. Is there anything else that you'd like to summate? We've got a few minutes left, and is there anything else that you would?
Well, I would just say maybe as a general comment, I've never considered myself other than a general veterinary pathologist. I've had various names hung on me. I'm not a British neuropathologist or anything like that. That's come up. And they usually identify me as a veterinarian, but I'm a general veterinary pathologist who has had unusual training to claim such. I've never had any formal graduate training in veterinary pathology. Mine was all, the graduate work I had was human pathology. But I think from early on, I may have been reading Dr. Bell's, the first page in his book when he talks about comparative pathology. And then, you know, completing the work I did in human pathology, going to Rocky Mountain Laboratory, working essentially with a group of medical people. It was in that milieu on mostly human diseases that I got sidetracked into the comparative side of things, and had no idea from the start that that was the direction I was headed. But it proved interesting, and I enjoyed the sort of things that I have done over the years. Well, and I now am going to regard myself as entirely retired.
Well, I hope that's not completely true, but we do very much appreciate
it's been a pleasure.
Your sharing all this with us. I'm sure it gives a wonderful perspective on the whole thing.
Thank you.
I also would like to say, as a colleague, that those of us in veterinary pathology are very proud to have you and recognize what you have done for our profession and the honor in which you are held by members of the medical profession and by our own. Thank you.
I'm pleased to hear that.
Thank you very much indeed.